So the point of Bitcoin is basically to be sound money. And there are other goals that we have now. We care obviously about like scalability, say, and we care about privacy. But soundness always comes first.
Hello there from Bedford, the Bitcoin mecca of the world. How are you all? Welcome to the What Bitcoin Did podcast, which is brought to you by the mighty Kraken, the best place to buy, sell and trade Bitcoin. I'm your host, Peter McCormack, and today I have a second discussion looking at Bitcoin and Ethereum, going a bit more technical, and this time I've got Andrew Poelstra, Tadge Dryja and Vitalik Buterin to look at this. I also asked Patrick McCorry to come on and help co-host this one, as it is a bit more technical, and, you know, I'm not very technical. But before we get into that, I do have a message from all my amazing sponsors. So first up today, I am welcoming back Least Authority as a sponsor to the podcast. Now, this one is for you techies out there, the builders who are creating applications. Least Authority is a security consulting company who are pushing the limits of how to build privacy-respecting solutions. They specialize in security audits, design specification reviews, and security by design. And they can help you improve the security of your wallet application, key management solution, layer 2 protocol, P2P network design, use of cryptography, and much, much more. If you want to boost your security strategy, you can arrange a no-obligation call to find out how Least Authority can help you on your next project. Just head over to their website and hit the schedule a call button, and that's at leastauthority.com, which is leastauthority.com. Next up, we have sportsbet.io, the best in online gaming, and with the Premier League back this week, like most of you, I am looking forward to Liverpool retaining their title this season, and also Tottenham having another disappointing season, another trophyless season. And we also have some extra excitement this season. I'll be following Southampton with interest, as Sportsbet.io have confirmed that they are the main club partner and front of shirt sponsors for them this season. And also, they are placing a Bitcoin logo on the shirt, not on the shoulder, not on the sleeve, slap bang in the middle of the shirt. Yes, every week, billions of people around the world watching Premier League football are going to be seeing the Bitcoin logo. I'm going to be working with them on some promotions and giveaways too, but if you are interested in gaming and you want to use Bitcoin, then head over to sportsbet.io, which is sportsbet.io. And also, let's talk about Casa, who are the best in Bitcoin security. With Casa, it could not be easier to protect your Bitcoin from hackers, personal mistakes, in-person attacks, device failures, and so much more. I am a Casa customer, and I'm using it to protect both my personal and company Bitcoin holdings. The peace of mind you get with this type of protection is very much worth paying for. And with Casa, they have a product for every Bitcoiner. With Casa Gold, you get triple the security of a hardware wallet for only $10 a month. With Casa Platinum, you get their 3 of 5 Multisig, the best protection for large Bitcoin holders at a great price. And with Casa Diamond, you get their full service offering. This includes a customized personal security review, inheritance, and of course, their best-in-class security. There is no better time to upgrade your Bitcoin security and get total peace of mind. Find out more at keys.casa, which is keys.casa. Okay, so onto the show, and following the show I made a couple of weeks ago about Ethereum and Bitcoin, I got some feedback from people saying it could have covered some more technical details, and it is unfair to judge Bitcoin and Ethereum as like for like. They are built for different purposes. Now, as anyone who is a regular listener of the show knows, I'm not a believer in Ethereum. I don't have any reason to use it and own any, but a recent comment from Shinobi in my 250th episode that says all Bitcoin are Bitcoin, including wrapped Bitcoin, I felt I wanted to understand a little bit more about Ethereum. As listeners know, I'm not technical, so when it comes to the technical arguments, I just can't have these discussions. So I got a few people on to have it for me. I asked Andrew Poelstra and Tadge Dryja to come on and bat for the Bitcoin side, and Vitalik Buterin to come back and talk from the Ethereum side. I also asked Patrick McCorry to co-host, himself an Ethereum proponent. Now this one does get really techie at times, and it's nearly 3 hours long. I was definitely lost for a bit, and for some of you it might go over your head as well, but it was still a great discussion. I hope you enjoy it. If you've got any questions, you can reach out to me. It's hello@whatbitcoindid.com. Outside of that, have a great week, and I'll see you soon. Right, big group of us this evening, so welcome to the show. How are you all?
I'm doing well. How about you?
Doing pretty good. How are you, Tadge?
Good, yep. Lots of fun, almost fall, getting cooler. It's nice.
Paddy, you well?
I'm good too. What a coincidence.
Yeah, I'm pretty well. I'm enjoying the isolation. It's been pretty nice.
No, I'm not. I'm used to traveling. I'm used to hanging out with these people in person. Anyway, I did a show recently where I had Vitalik on with Samson, and depending how you kind of depending on your position, you either thought that was a very good show or it was an absolute car crash. Samson did exactly what I expected him to do, but it didn't allow some, I think, a bit more nuanced discussion in some areas. And so I spoke to Vitalik and I said, is there anyone else you'd like to talk to where we could maybe just kind of advance a couple of areas? And he said, I'd be very happy and interested to talking with both Tadge and Andrew, respect them both greatly. And Andrew and me and Tadge and I have also recorded some great shows. And then obviously, Paddy, you put out that you're willing to help moderate, which is great because an awful lot of things tonight we will talk about I won't understand. First time I've had a co-host for a show like this, which would be interesting. So I'm going to hand over a lot to you, Paddy. But I will jump in occasionally and just say, look, come on, I need a bit of a better explanation than that. The only starting point that I really have is just, this is going to be kind of a repeat of a question for you from last time, Vitalik, but I also think you should answer, Paddy. And then, but it's the same question, but for the other protocol for both Tadge and Andrew. And this is my starting point, and then I'll hand over to you, Paddy. Is that okay?
Yeah.
So one of the things that came out of the last interview is people said it was you framed it as a Bitcoin kind of versus Ethereum show, Pete, and they're trying to do two different things, which is a fair point. But it's really interesting to hear people from their opinion what they think something's trying to achieve. So, Andrew, starting with you, with Bitcoin, for you, what is Bitcoin trying to be and what's it trying to achieve?
So that's an interesting question that has a bit of history to it, I guess. So originally, of course, Bitcoin was created by Satoshi. The first block that was mined had that quote from the London Times article talking about bank bailouts in 2008 and 2009. And that sort of established the sort of ethos of Bitcoin as being sort of like a libertarian, like sound money. The goal of Bitcoin was sort of to be an alternative form of money where the inflation schedule or where the monetary policy was set in stone. And it was, rather than being controlled by political considerations or by central banks or whatever. And kind of weirdly, the idea that Bitcoin was electronic was almost like downplayed. Like it almost wasn't an important thing. The idea was there would be some sort of money that anybody could use around the world, and that you could use, but also that you could use it online. So right now, the money that we're familiar with using online is basically all like, it's you're using a credit card, you're writing checks or whatever. The money that you can use on the internet is not a bearer instrument. Bitcoin is a bearer instrument, meaning that you can hold it. If you physically have the Bitcoin, then you control the Bitcoin. And unlike other objects where when you physically hold them, you have them, you're able to transact this across the world using the internet. So you're not forced to go to some third party to enable your transactions. So the point of Bitcoin, to be brief, is basically to be sound money. And there are other goals that we have now. We care obviously about like scalability, say, and we care about privacy. But soundness always comes first in Bitcoin's mind. And money also always comes first. Bitcoin isn't trying to be a world computer. Bitcoin isn't trying to be like a token platform. Bitcoin isn't trying to be like a DNS server or like a file storage place or any of the other ideas that people have come up with over the years and tried to use Bitcoin for. It's trying to be money and it's trying to be sound. And I guess that's my answer.
Just one thing to ask, to add on to that. You said it's trying to be sound money, but we also care about privacy. We also care about scaling. But would you not say privacy and scaling are characteristics of sound money?
So when I say soundness, what I mean very specifically here is that you can verify the history of the system. You can verify that the current distribution of money, whatever that looks like, is the honest distribution of money. Nobody like came in and then shuffled stuff around. There was no like secret meetings that caused the money to move around. You sort of know where it's coming from and where it's going. I would say privacy and scalability are critical to being useful money, are critical to being a money that enables a bunch of other societal goals. But just the word sound, I mean that in a very narrow sense.
Okay. Tadge, how about yourself? Would you agree with Andrew, or do you have anything else to add on to that? Any different opinions?
Yeah, I can add a little. I generally agree that that's what it's about. Sound money. It's the blockchain stuff. So most of where I work, I guess a lot of times I talk to people about blockchain, and there's a lot of students at the business school and things like that, and they're like, oh, but there's this blockchain stuff, and you've got all this data, and you've got traceability, and you've got these things. It's like, yeah, those are all bad. Those are all liabilities. We can do identity on the blockchain. I'm like, yeah, no, all of these properties are detrimental to Bitcoin, right? The goal of Bitcoin was, as Andrew said, sound money, and all of these technical things that people have sort of latched onto are like sort of warts on the system that we are trying to get rid of, and probably never can totally get rid of. So yeah, the blockchain is a liability, the traceability is a liability. I also think that the set in stone part is really interesting. I personally don't really care about only 21 million Bitcoins. And maybe that's like sacrilegious, but to me, if Satoshi had said, okay, the block reward is 1 Bitcoin per block forever, and okay, fine. To me, it doesn't really make a huge difference. But I understand that one of the properties of Bitcoin is that it's really hard to change, and the set in stone to some extent is a societal thing, right? Anyone can change the code and run different stuff, but the fact that we all sort of agree that we can't means that we can't. And so I'm trying to defend the monetary policy of Bitcoin, I guess, even though I don't really care about it. So that's sort of an interesting aspect of what makes it sound money, I think.
That's a very controversial point. I think you and I will have to talk about that another time, because some people will. Some people will actually.
Fine. Okay, yeah. I think it just isn't as big of a deal as most people make it out to be. But yeah, but I'm fine with it. So.
Okay, so just then flipping over to Ethereum, and sorry, Vitalik, because I know you did this last time, but perhaps it'll be a new improved version. But can you answer the same question for Ethereum?
Yeah, so in Ethereum, the protocol was, and the idea was born in this kind of environment where, you had Bitcoin and you had Namecoin, which was this early version of basically a thing that we call predecessor to things like ENS and Handshake and other things that exist right now. We had colored coins trying to issue assets on blockchains and other protocols. And so the original goal of Ethereum was basically to try to see, can we basically take a blockchain and take the properties that a blockchain provides and kind of generalize them more, right? And basically, instead of just being able to create a system of money where you can kind of verify the history, ensure that the rules are going to be followed, ensure that the rules are going to be hard to change, and all of these things. Try to apply that to other kinds of applications as well, right? And try to kind of create a platform where you can build applications more generally, where you can kind of agree on a set of rules, and unless the people who are changing or who are participating in the application are kind of all agree to basically either upgrade it using the application's own rules or just switch to another one. Unless they do that, then the rules that they are kind of participating under are going to be the thing that they agreed to, and there aren't any kind of sneaky backdoor ways to go in and change it. And so the idea is that that's something that's obviously valuable for a currency. It's valuable for a lot of kind of financial applications going beyond the currency. It's valuable for potentially non-financial applications, and if things like domain names are probably being a big one. And so to just kind of create this open playing field and see what people end up building with it.
So Paddy, you're a fellow Irishman, although you're from the northern part, right?
Yeah, I'm from Belfast. Yeah, wonderful little Belfast.
You can tell by this strong accent. Some people don't realise, but if you're some Irish and you know both. Listen, look, Tadge and Andrew have both been on my show before. People know who they are, and people will know Vitalik because, he's Vitalik. Come on. But people might not everyone listening will know who you are. Can you just let people know who you are, what you do, Paddy?
Yeah, so I got started in the cryptocurrency world back in 2013. I was an undergraduate at the time studying cryptography. And my advisor told me, my PhD advisor, or soon-to-be PhD advisor, told me about this thing called Bitcoin being used in the dark web. And I thought, that sounds quite interesting. Let's jump into that. And so when I first discovered Bitcoin, there were really two different narratives that were happening at the same time. One was the payment narrative. We go on Silk Road, you buy some candy on Silk Road and it gets sent to your house. And it was advertised as global, decentralized, anonymous currency. And obviously, as we learned in the next year or two, is the most traceable public currency in the world. So that was like the payment side, and that's why I got interested in. And then there's the second narrative that both Tadge and Andrew were talking about, which is this, protection from fractional reserve banking and limited inflation, and being able to see the money supply and being sound money. But the question is, why are cryptocurrencies, why do they give you this sound money property? And that's because of, the cryptography, in the sense that I can download the entire transcript of Bitcoin. I can download all the transactions that have ever occurred, and I can independently verify everything that's happened in the past. And that's sort of like the strong narrative that comes out in Bitcoin. Now, so far in Bitcoin, that's only really useful for financial transactions where you want to send coins back and forth. And partly for Lightning, which we can talk about soon, which is like a special type of smart contract. So what got me excited about Ethereum was that you could take this idea where I could verify everything the counterparty is doing. I can hold them accountable, and you can actually extend that functionality. So one great example of that is Uniswap. I can go on the Uniswap website. I can swap, my ETH, the sushi, and sushi to some other terrible token. But I can do it in a way where I don't have to trust anyone, and I can verify everything that's going on. So now would you actually have a verifiable agreements where you don't have to trust the counterparty? So it sort of takes the idea in Bitcoin where everything's verifiable and then brings that forward to Ethereum, which is what got me interested in it.
Right.
So that's sort of the answer to, why is Bitcoin interesting and why is Ethereum also interesting?
So the angle I'm always interested on these shows is, and I expect today we're going to go quite technical, and I think I don't need to always repeat how untechnical I am. But the reason that I'm interested in these shows and for my audience is that based on the information that you may provide today, people might treat this as an opinion that might help them make a decision whether they want to invest in something or not. But at the same time, I do understand today we might get into some quite technical things. So I'm going to hand over a lot of this to you, Paddy. I might dip in occasionally and say, come on, explain that a bit for me. For anyone listening who doesn't know me, I've invested a lot of cryptocurrencies historically. I don't anymore. I only hold Bitcoin, and that's all I care about. But I have bought Ethereum in the past, a long time ago, and I did make some money of it. But I took the podcast at Bitcoin only, and that's what I'm focused on now. I don't have a huge interest in Ethereum, but I am willing to listen to these conversations, and it would be really interesting. Just for me, this is just very interesting to see Tadge, Vitalik, and Andrew all kind of talk about things, and I don't know what's going to come, but I'm very interested in that. So, Paddy, I'm going to hand over to you, and I'll just dip in as and when I think it might be required.
Yeah, that's awesome. I can sort of start off with this sort of Bitcoin to Ethereum transition now. So I think throughout the show, we're going to cover really basic three topics. One is the origin story of Bitcoin and Ethereum, which we sort of just done in a way. Then we're going to move into sort of how both systems are like Frankenstein-like systems, and they're both sort of really ugly and horrible under the hood. And how well can we build self-custody protocols on top? And when I say self-custody, it means I can interact with the counterparty. I don't trust them, and I still hold full custody of my coins. And afterwards, because everyone here is basically a researcher, obviously, so what I'm going to move on to is sort of future scalability of both networks and how they're both approached by everyone in this call. So I think that'll be quite interesting for everyone. But what I want to first start off with is the Bitcoin world. So Bitcoin to Ethereum. So as we know, Bitcoin had these narratives: protection from inflation and limited and fractional reserve banking. That was clearly in the white paper, in the Genesis block. It was on the Bitcoin website in 2009 to 2010, 2011. I think it was removed around 2012. And also this idea of this truly peer-to-peer payment network. But as sort of Vitalik alluded to, there was this third thing evolving in Bitcoin, which Satoshi never really planned out, which were these several new applications, sort of like Color Coin, will eventually become OmniLedger, and also games like Satoshi Dice. Now, I remember Satoshi Dice. That was about 2012, and that's when I first started looking at Bitcoin before I did my PhD. And Satoshi Dice wasn't really welcomed on Bitcoin at all. It was very hostile. It was this basic gambling game where I send a transaction to basically the casino gives me a hash. I send my bet inside the Bitcoin transaction. If I win the bet, they'll return the transaction to me with my prize. Otherwise, I can verify why I lost. And that was considered spam on the network. It was filling up the blocks. And there was one really prominent core developer who I won't name. And he's also very active in the mining area where he basically threatened to censor these Satoshi Dice gambling games. So I wanted to get your opinion on this, Vitalik. What was it like when you moved into, you obviously picked up on a lot of this for Bitcoin and you thought, well, maybe we could build a new platform for doing this on Ethereum. What was your take on that? How did this influence Ethereum?
Mm-hmm. Yeah, no, I remember Satoshi Dice quite well, and it's definitely, I thought at the time it was a wonderful kind of use case of the blockchain, a kind of clear demonstration of how, if you have this decentralized platform, you can get a lot of these extra security guarantees that you would not be able to kind of get in a more traditional way, right? And it even used the blockchain in a kind of going a little bit beyond as a payment rail, right? Like, as I recall, it even used block hashes for like one of the inputs to the randomness. So like, it's clearly using it for one small thing that's other than just a way of moving money between you and Satoshi Dice and back. So when I was first starting Ethereum, this was actually in the context of when colored coins and Mastercoin and some of these even later protocols that were trying to use the Bitcoin blockchain were happening. And they were taking this kind of non-currency use of the Bitcoin blockchain idea even further, right? They were saying, let's send transactions on chain. And from the point of view of the Bitcoin protocol, these transactions just look like they kind of have some junk data. But from the point of view of our own protocol, from the point of view of this piece of code that we're going to send to users and that users can download and run themselves, they can basically kind of interpret the Bitcoin blockchain. So, imagine creating a language where like the way you speak the language is you kind of say a sentence in English, but when you say your sentence in English, like you choose synonyms so that if you take the third letter of every word, you actually get a sentence in some other language, right? It's that kind of hiding going on. And they would kind of metaphorically read the third letter of every transaction, so to speak, and see, are there these operations in this other protocol? And based on that, the transfer of issued token and financial transactions involved issues. And like to be fair, like there's a lot of people say I import ideas and they were mean and they rejected me and so forth. Like that's not what happened, right? That's it was more that like there was this existing climate where there were a lot of people who were kind of not in favor of these kinds of applications and said things like, the blockchain should be used for the currency. And so I figured, okay, well, it's better to kind of start the platform on top of a kind of community that wants these things to happen. So at first I was considering the Prime Coin community. This was one of the bigger altcoins back then. And then I was also starting to do that, but then the Ethereum community kind of got much bigger than I expected, and like that's when I realized that hey, there is actually enough developer mass that it's kind of possible to create a separate blockchain, and so we ended up creating a separate blockchain and going from there.
That's pretty cool. So just to summarize that, because that was quite a long answer, I guess there's 2 points to it, isn't there? One, the issue with Mastercoin and Colorcoin was that you basically this new protocol was added on top of Bitcoin. Bitcoin itself was not aware this existed. It was unable to enforce the rules. So if I wanted to, I could try to make myself, mint myself master coins, and the Bitcoin blockchain wouldn't do anything about that. All the validation was client side. So my software that would read all the master coin transactions would have to enforce the rules, and Bitcoin couldn't do that for me. And obviously for Ethereum, you wanted the platform to enforce the rules, not necessarily the users of the protocol or the app. And then the second one was that the community itself, you sort of had this idea that Bitcoin was sort of not hostile. This is word welcoming of the idea. You entered the Prime Coin community because they're more welcome to it. Then you thought, well, actually, I've got enough critical mass. Let's just go for our own blockchain and see what we can build. Mm-hmm. Cool. And go ahead, Andrew. Jump in.
Okay. Yeah. So let me respond to a couple of things that Vitalik brought up. So as you say, there's sort of two things that Vitalik was discussing. One was counterparty or colored coins or whatever, and the other was Satoshi Dice. Regarding colored coins, part of the opposition to this was not only an opposition to using the chain for too many things, but specifically using the Bitcoin blockchain or any particular blockchain for multiple assets introduces some scary changes to the incentive model, where your miner fees are always denominated in Bitcoin. They're always denominated in the primary currency. But there's a concern that I think actually applies to Ethereum as well, where if you have an ecosystem of many different tokens, and that ecosystem is much larger in terms of economic activity than your primary currency, then you have a situation where your chain security, which is incentivized in terms of the primary coin, is paid for by something that is different than the asset that people who are actually using the chain are using. So there's this disconnect between the usage and how you pay for it. So that was part of the opposition to colored coins. But there was also, and I think this is really much more what Vitalik encountered, an opposition that we saw both in Counterparty and in Satoshi Dice and so forth, of using the Bitcoin chain for things that weren't Bitcoin because this was putting work on Bitcoin validators who simply wanted to be validating Bitcoin. And one thing, so my recollection of Satoshi Dice, I just want to really bring up this story, is at the time, pardon? Tadge?
Oh, wasn't that awesome? Go ahead.
Yeah. So when Satoshi Dice came out, as Vitalik maybe described, the way it worked basically is you would send some coin to the Satoshi Dice server, and then if you win, they flip a coin or whatever, and maybe they send your coin back with some extra coins. So every single bet required a transaction, and every win required an additional transaction. And this was, as Paddy mentioned, there was a certain Bitcoin developer who at the time had a significant amount of hash power who really did not like this and was actively trying to the extent that he was able to, which at the time was non-trivial, and hopefully today we would hope that individual miners have trivial ability, but that's another thing, was trying to censor these transactions. The issue that I had with Satoshi Dice was that it was so needlessly inefficient, because at the time we had this scheme called probabilistic transactions, and you can Google this, Bitcoin Wiki probabilistic transactions. This idea from like Mike, the Cassius coin guy, Mike Cadwell, I think, from like 2011 or 2012, where you could do a probabilistic payment, a probabilistic payout, using only a single transaction for people who win. So there are a couple pieces of this. I'm not going to go into the details, but my point is that there are sort of maybe more efficient ways that Satoshi Dice could have been implemented that wasn't needlessly producing a tremendous amount of transactions. And similarly, the way that Counterparty and the way that other colored coin schemes were implemented, there were components of this that were also needlessly inefficient. And so there's simultaneously this viewpoint. There are two pieces to the opposition, I guess. One was this opposition from Bitcoin people to using the Bitcoin chain for anything that wasn't Bitcoin. But the other was this desire to like really just minimize what's hitting the chain entirely. And since I don't want to like take up all the time, I'll just say you can Google. I have a talk from Scaling Bitcoin in 2017 called "Using Chains: What Chains Are Good For," that I think we'll come back to in a later section of this discussion, about just really trying to not use the block as much as you can get away with it. As much as you can get away with it to do cool stuff without actually using the blockchain, or like really minimizing the amount that you touch the blockchain.
This is one of the points I just want to jump in. So I think what you're trying to get at here, Paddy, is that essentially Bitcoin's meant to be censorship resistant, and that is somebody's trying to, whatever you think of Satoshi Dice, if fees are being paid, if the blockchain is available for you to use as you want, nobody should be able to censor this. But at the same time, I'm also thinking like Bitcoin's very early at this point. I mean, I've read the old Bitcoin talk threads about this, where there was seen as a lot of spam on the network. So what would happen, do you think, Andrew, if somebody was to do something similar today? Or do you think the network is mature to a point now where it's basically not affordable because of the fees to transact?
That's a good question. So the reason that Satoshi Dice went away is that the specific mechanism they were using, which is chaining unconfirmed transactions off of each other, caused them to be just like easily exposed to double spend attacks. And I think they were actually like attacked in a pretty dramatic way and had to fold. I think it's probably possible to do something like Satoshi Dice, maybe a bit slower, where you didn't have that issue. And in which case your question is more interesting. Suppose somebody tried to do that today. And I think what they would run into is that if they tried to do something that gratuitously inefficient, they would just be priced out of the market. You wouldn't be able to run a service like Satoshi Dice. Unfortunately, if you are, say, a large exchange, say running a very high margin Bitcoin business, you are able to do tremendously inefficient transaction patterns. And you can just afford it. Right now, any large Bitcoin exchange or any large cryptocurrency exchange just has such a tremendous amount of revenue relative to the network cost on Bitcoin that it's still possible today to do gratuitously inefficient transaction patterns to execute even like very simple protocols, like just like paying out your users when they ask you to withdraw money. So I guess we've seen, in some sense, like a transition away from things like Satoshi Dice, where it was just kind of comical how inefficient they were. But we're still at a point where, as you say, Bitcoin is very early, and you can do things which maybe in 5 or 10 years we're going to look back on and say were comically inefficient. Maybe we're going to see a trend towards those kind of things being priced out. Because I think as long as you can afford to be silly on the Bitcoin blockchain and just like pointlessly waste space, that's something that we should be concerned about, because that ability to afford being silly is identical to the ability to afford, messing with the blockchain security, the ability to afford like trying to rewrite the chain or something like that. Like you really would like the people to be spending as much as they can on security and caring about the cost of securing their transactions.
Okay, fair enough.
I can just add a little about that. I think it's this also, maybe 2012, 2013 was more of this, but even today, the idea that, okay, there's things you can do right now in Bitcoin, but we don't want to give people the idea that they can do those forever, because then when you take them away, they get really mad and do things like make Bitcoin Cash. And that's what happened years ago, where there's a lot of people who were working on Bitcoin and saying, no, I was promised, instant free transactions, unlimited. And it's like, well, wait, who promised that? Because most of the developers working from the very beginning were saying, okay, scalability is going to be a big issue here, and worrying about Satoshi Dice. But that doesn't always, get through to people. And so that was, I think, one of the big worries with Satoshi Dice, as well as later things, that like, okay, if people really get into this and like it, and all your users are Satoshi Dice users, this isn't a sustainable path forward for Bitcoin, because it's not really going to scale. Whereas maybe some other things might scale better.
Vitalik, do you have a comment before I make a comment?
And it's interesting to kind of think about these topics in light of like the approach that Ethereum took, where I think, and this is less of a technical difference and more of a philosophical difference, where I think the community is much more on the side of, we don't discriminate. If your thing pays the fees, then go for it. Which is definitely, I think, in some ways a reaction to this kind of approach of kind of more trying to say, the chain is intended for these things and not for these other things. And like you can see the kind of more of the Satoshi Dice like worse is better philosophy, I guess you can call it, like in Uniswap, for example, like to kind of give a topical example, right? Like if you talk to traditional financial people, like I'd say, like Uniswap is crazy. Like where's the order book? Like, why would a market maker even wants to just like create this and like blanket, like X Y equals K curve instead of actually being able to kind of choose their limit orders more efficiently and kind of drag them around the way they do in traditional exchanges and so forth. But the reality is that if you look at the last 3 years, kind of simple and dumb won, right? And as of a couple of days ago, simple and dumb X Y equals K, as Uniswap has more volume than Coinbase. So there's something to be said for kind of the simple and dumb thing that kind of feels ugly on paper, but at the same time, has these kind of benefits. In Uniswap's case, I think kind of user experience was a big one. Like I think one of the predictions that I made with Uniswap, for example, was that like DEXs can have higher usability than centralized exchanges, which sounds surprising, but it's possible because the decentralized exchanges are on chain, and so to use them, you just like go to this other website and you just open up MetaMask and send a transaction, right? You don't have to create an account and then deposit your coins and then do confirm over here, then do some other things and withdraw your coins. And Satoshi Dice, I think, appealed to people because it had that similar feel. But on the other hand, Uniswap does have these kind of challenges around, well, right now, transaction fees. Now, one thing I will say is that one of the reasons I think Uniswap won is that its gas usage is vastly lower than a lot of the other DEXs that came before it. Like Uniswap is like in the 50 to 100,000, but a lot of these kind of previous ones are 200,000, 500,000, 700,000. Back then they didn't care much, but so it's made all of the kind of improvements that it can make, but even still, it turns out that people really like being able to exchange between assets on chain, and so now it's like somewhere between a sixth and a third of Ethereum's kind of activity. So you can see the cost, and you can also see the benefits of the philosophy. And from a security standpoint, it's Ethereum transaction fees have been, I guess, averaging over a longer time frame, like somewhere between, I guess, a quarter and as high as the mining reward for the past month or so. On some days have gotten higher, but on the other hand, transaction fees being high means that some people have to pay those higher transaction fees. So it's a balance.
Yeah, I think there's a lot to unpick out of these three answers. So I'm going to try to pick them out a little bit so people don't get lost in the weeds. The first is sort of the use of the blockchain. So the point of Satoshi Dice was because they had all these chains of unconfirmed transactions, that was seen as a waste of the Bitcoin blockchain because, the goal there is to make it so, 99% of the population can verify the blockchain in its entirety. And we have all these wasteful transactions, and it just adds bloat to the time it takes to verify the blockchain. The other part is fees themselves and why people would pay fees to do something. So as we're seeing on Ethereum today, the fees are a bit ludicrous and crazy at the moment. But that's also because if they do trade X, if they do transaction A and they pay, they pay X, but that transaction is going to make them Y, then they're willing to pay, from X up to Y in order to make profit from it. Basically, as long as that transaction is profitable, then they have a financial incentive to run that transaction.
Can I ask a question there, Paddy?
Yeah, go ahead.
So I agree with this idea that essentially the blockchain is a free market, and as such, the prices are dictated by supply and demand. It's more of a question for Vitalik, though. Has this massive increase in prices priced out any other particular uses of the blockchain that has you concerned?
Mm-hmm. It has. And we can see that there are applications that 3 years ago would have been on mainnet that right now are living on testnets, right? So especially the non-financial ones, a couple of weeks ago, the thing that was popular was this Dark Forest game, right? That was basically using zero knowledge proofs and the blockchain in this kind of really clever way to basically implement this game that has to do around jumping around different planets and exploring space, and if you find someone, then you fight them and all these things. And the transaction was running on the Robson test network, right? Which now, obviously, if you're running on a test network, it's much less secure than all of these things. But they did have no choice, right? Because if they had run it on mainnet, it probably would have cost all of the players many thousands of dollars, and it would just not have happened. So non-financial use cases are definitely having a really hard time now. And it is definitely a concern some people might say a concern. Some people might say, blockchains are primarily financial tools all along, and this is what's supposed to happen. That it's the financial use cases that if you have limited space, end up outbidding the less financial ones.
See, what that says to me is it kind of reinforces what I like about Bitcoin. It essentially tries to do one thing very, very well and very securely, which is the movement of value around the world, and it's like a tank for that. And it also kind of reinforces, I think, why Satoshi Dice wasn't such a great idea for the Bitcoin blockchain, and in some ways, it's kind of highlighting them same issues now for Ethereum. So in some ways, I wonder if that changes the future. I wonder if other people would move to other blockchains, certain ideas, or that will change, maybe narrow what people think Ethereum will be used for. Because if you've got projects which can't get off testnet, or are these things that will be solved with ETH2?
Yeah, and the various Ethereum scaling technologies, I guess, combining ETH2 and rollups are definitely the thing that the ecosystem is going full speed ahead on right now. I know that there's a lot of projects that are increasingly looking at the rollups because the rollups are much shorter term than things like sharding, right? That'll probably take maybe potentially 1 to 2 years to get out there. Whereas rollups, the optimistic ones are coming in a few months. The ZK rollups that are, they use fancier technology, but they're actually simpler because they only support a couple of applications instead of general purpose smart contracts. Like some of them are here already. And one of the things that I heard recently is that Loopring, this is this decentralized exchange that's running on top of a ZK rollup. They are integrating a Uniswap-like automated market maker into their platform, I think starting from the next version. So I definitely think that people should not be rushing to conclusions until the scaling technologies are ready. And when they are, we will see. I can see one of a couple of outcomes. One outcome is that transaction fees kind of durably get cheaper again. The other outcome, which is both less and more optimistic, would be one that says it just the possibility of scaling attracts a much larger amount of usage, and because you have 1,000 times more space but 1,000 times more users, we're kind of back to square one, and it's a financial platform, but it's a financial platform for many more people than there are now. So and it turns out that for technical or security reasons or whatever, we will not be able to scale it even more beyond some point. So I see those two futures, and it's also possible that we'll be able to scale to many more users and be cheaper for those users. We'll see.
So if that happens, then you'll be announcing ETH3.
So ETH3, I mean,
come on, that was a joke. You actually have an answer.
I definitely have kind of thoughts on E3. This is one of those things that kind of different people in Ethereum have different opinions on. Like Justin Drake is kind of excited about E3. I'm much more in the kind of ETH2 is the end of history camp. Basically, this is a kind of technical rabbit hole that's probably too rabbit holey for a Bitcoin audience. But I think there are limits and kind of complicated trade-offs on how far you can scale a sharding system. Basically, the higher the higher the number of shards that you push, the higher the minimum number of users the system needs to have in order to be safe. And so as you scale it up more, it becomes more brittle. And so if ETH2 and rollups on top of ETH2 can't fix it, then basically nothing can, because you would just unacceptably punish security to try to kind of push the system to its limits. But much more rabbit hole topic, so maybe talk about it some other time.
Yeah, I think you should get ETH2 out first before we get onto ETH3. All right, Paddy. Sorry to interrupt you.
Oh, no, it's fine. So I think what we can do is we can focus on how Bitcoin and Ethereum work today for the next little bit, because they would bring up. So basically, we've got to the point where we're going to talk about why they're Frankenstein systems, and then we're going to talk about scalability. So we'll touch upon rollups, Lightning, and hopefully current ways that we can scale using the same hardware. So we've sort of basically got to the Frankenstein topic just before we got into the tangent about rollup. So why do I call these Frankenstein systems? Because Satoshi Nakamoto was not a very good programmer. There's plenty of bugs inside the early Bitcoin core software. Some that I've made a little list here. So back in 2010, there was a bug in OP return that would allow anyone to steal anyone's Bitcoins. Multisig has a bug. At the start of a multisig script, there's a 0. If you forget your 0, then you're going to run into problems. Several opcodes were considered dangerous, and they were just disabled altogether. When you verify a Bitcoin block, you actually create this Merkle tree. Was you hash every transaction, you build a little tree, and the root of the tree is the commitment to all transactions. That's not implemented correctly in Bitcoin either. There's a bug on how the last bit of the tree, duplicates the transaction. So there's so many little quirks in Bitcoin that make that really horrible. Ethereum equally has another list of bugs that I'll hopefully get into soon. But one of the things I wanted to highlight was actually we're going on to the waste of Bitcoin block space topic. So Bitcoin has this model.
Can we just go back a step there, Paddy? Just as you raise a number of things like that other people might not be aware of or heard of before. Andrew, can you just respond to that? Like, are these things that are known and frivolous? We shouldn't care about them?
Yeah, as a Bitcoin user today, you don't need to worry about any of these things. These bugs have all been either fixed or somehow shimmed around. So these aren't active problems with Bitcoin. There are historical things that, as Paddy says, are kind of surprising that you would see a bug like that.
These are like 2010 bugs.
Right, yeah. We're talking, most of these have been fixed for, a couple of them have been fixed for literally 10 years. I think most of them have been fixed for more than 5. So this is all historical stuff that does not affect Bitcoin today. And they are all well known within the Bitcoin OG developer community.
Okay.
Yeah, so these are well-known bugs. So one thing I wanted to bring up first was the waste of block space. And so if we consider Bitcoin versus Ethereum, this is one topic I find very interesting that I used to give to students at university that, make them puzzle them a bit. So in the Bitcoin world, every time I get a new Bitcoin, so if you send me a Bitcoin, there's the UTREEXO model, and the idea that every time you send me a coin, there's a new entry in the ledger that my address has this coin. So every time I receive new coins, there's this new entry in the ledger. And it's a bit like a wallet. I could end up with 10 different sets of coins. And when I want to go to spend my coins, I create a transaction. I pick, maybe 2-3 different of these outputs, these coins, and then I send them in a transaction, and then I basically compress them into one output and I send them out. So, but the main point there is every time I send you a coin, there's a new entry in the ledger. And when you create a transaction, you're going to have to pick several of these entries. In the Ethereum world, it's the account-based model. So every time you send me a coin, it just increments my balance. As you would expect an account-based model to work. When I spend my coins, you just check if I have enough coins in my balance, then I spend it. Now, back in, I think this is 2017, maybe 2018, Coinbase got a lot of flack, a lot of bad press because they had 1.5 million UTXOs that accounted for, let's say, 250 Bitcoin. It was around that region. But because they had so many ledger entries, these outputs, it was not economically viable to spend the Bitcoin. Because every output was $5, $3 or something, but they add up to 200 Bitcoin. Now, to get around this, what Coinbase have to do is they have to wait until the fees on the network go really low. Then they create transactions that basically batch all of these entries into one. And all they're doing is managing their coins, and they have to create Bitcoin transactions and send that to the network. Now, my question would be, is it Coinbase's problem that, should this be Coinbase's problem? Should they have to manage their UTXO? Do they need to do this batching? Is this not just a waste of the Bitcoin blockchain because of a problem in the protocol? So, and in the account-based model, this doesn't exist because you just keep topping up the same account. So I just want to I seen Vitalik unmute himself, so I'll let Vitalik go first, see what he thinks.
Yeah, no, I mean, I'm sure that I can imagine Andrew would even be able to kind of describe the justifications for the UTXO approach even better than I can. But as Paddy mentioned, there's definitely frustrations with it. I even remember experiencing this myself back in 2014 when we were doing the Ethereum Ether sale, right? And we had this one address that gathered together. It was 9,003 inputs or something like this, and these were all in a multisig cold wallet. And so what we had to do was basically just generate scripts and come up with and send this huge number of transactions on chain that kind of gathered up all of those transactions that kind of combined them together into a hot wallet. And then the software we were using had kind of limits on how much you could kind of batch together at any time. And we started off by kind of grabbing these kind of the big kind of outputs that we received. And then when we got to the small ones, there was a whole bunch of dust. And eventually we just, when there was not too much money left, I kind of took all 4 private keys on all 4 different kind of machines, exported them, put them all onto my laptop, and then just wrote a script to generate the rest. So there's definitely a lot of, it was a time consuming and kind of not user friendly process. And This wasn't the only time. Like, there was also a time in 2013. This was when I was writing a Bitcoin, basically Bitcoin wallet software, and started to kind of run into some similar issues. And like, one of the issues was, I think, that if you want to, let's say you want to send a transaction that has a coin, then you have to figure out what the fee is going to be, but then that fee adds a bit to how much you have to pay. And then what if the amount that you have to pay requires a kind of adding an extra output, and then that extra output increases the size of the transaction, which increases the fee, and then a bit of a recursive loop. So there were these kinds of things, and I think you can say that they kind of contributed to motivating Ethereum's kind of account-based approach. And now, of course, at the time, I kind of didn't really understand well what the kind of technical benefits of the UTXO-based approach are. And now, we have kind of a much better handle on those arguments. And either here or at some point, we can talk about some of the things that we're doing to try to kind of move toward getting the benefits of both approaches at the same time. But it's definitely complicated and a lot of trade-offs.
Yeah. Go ahead, Tadge. Oh, sorry.
Do you want to
go ahead, Andrew?
So I can counter with my own user experience story about the account model, just to emphasize. So Vitalik is correct that as a wallet developer, so users don't need to see this, but a wallet developer needs to think about this. There are difficult computational problems related to doing this optimally. And it gets complicated and it's difficult to manage. And I can comment a bit later on some benefits on sort of the technical design decision. But certainly from a user point of view, it can be frustrating to manage a bunch of UTXOs, especially when you find that some of them are very small and their value is no longer sufficient to pay for their own spending. But the flip side of this, though, is that the UTXO model lets you, as a user, when you're receiving funds, to generate a unique invoice number, or an address, I guess is what we call it for Satoshi reasons, a unique address for every single payment. And so when you receive coins, you have an easy way to identify when you received money related to a specific payment request, to a specific invoice or a shipment or whatever, your user or what have you. In the account model, or in the way that Ethereum has implemented it, you as a business, if you try to have only one account that is receiving coins from all these different users, it becomes difficult to identify which specific payments come from which users. You can look at the transaction and look at the spending account and try to identify users that way. But that makes it hard for users to use multiple wallets and makes it hard for users to spend coins from different smart contracts. It in general restricts the way that users are able to use the system. So, and then if you instead try to receive coins, if you say try to attach an identifier using a smart contract or something like that, then you find yourself having to write Solidity or having to write some sort of contract just to receive coins, which I've talked to a few wallet developers who get very antsy about that. They get very scared and they wish that they could do something simple. Another approach you might try is to say, well, I am going to have a unique account for every single user. I'm going to receive coins to that account, and then I'm going to have my own code which forwards money from the temporary account to my real account, and then I'm going to have all my money in the same account. And the reason that you need to do this sort of consolidation step is that when you're spending coins in an account model, you can't spend from multiple accounts at once. If you were doing that, then you'd basically be in the UTXO model, right? So because you're always spending from a single account, you need all your funds to come into a single account. And then that makes it more difficult to distinguish between different payments that might be coming in different orders from different paths across the network and so forth. And as a wallet developer, I'm kind of curious if there's a standard solution to this from the Ethereum world, and maybe I just don't understand it. But
I can comment a little bit as well, actually. I had a similar problem. So the point there is that how do you identify the person sending you money? That's the basic problem here. And what you do in Bitcoin is that you give the person paying you money a new Bitcoin address. And if you get money to that address, you can say, well, Bob paid me money. And in the Ethereum world, people always tend to reuse the same address. But now if I get 10 payments to the same address, I'm like, well, did Bob pay me? I don't know. And I don't think there's a payment protocol in Ethereum, because someone pinged me about this issue. Because what you could do is have a payment protocol where maybe the sender pings the receiver to say, here's the transaction I paid you. And this is, I can prove that I own this account. But that doesn't really seem to exist. And the transaction does have a memo field. It would be really nice if it had a memo field, because then you could just put information in the memo alongside the transaction.
It does, right? Like Ethereum transactions do have the TX data field.
Do they? Oh, they have a data field, I guess, but I guess you could just put random data in there.
Mm-hmm. Yeah, you can put as much data as you want as long as you're willing to pay the 16 gas per byte for it, which for a memo is pretty tiny. Yeah, and I think if the Ethereum world, like there's a couple of different solutions for this. Like the one that I think a lot of people use is just because it kind of maps the most closely onto their existing practices in other blockchains. It's just like Andrew's solution of like give a different address to each user and then run your own code to consolidate. Like that's what I think exchanges end up like just doing. And I mean, it might be kind of on net the most convenient for them because it lets them have the same workflow across all the different chains. The second approach would be to like not have a contract on chain, but to kind of ask senders to include transaction data, and then you would have code that goes into the transactions that checks what their data is. And the third would be, and it's I guess philosophically the most correct approach, but I kind of agree that the Ethereum ecosystem hasn't done enough to kind of make it easy to do this, is to write a contract, and that contract can have a function, and that function would take an argument, and the function could even do something like respond back by kind of giving you some ERC-721 or some other token that basically kind of specifies that, you paid for the thing, and so it would be a payment and the ticketing kind of system at the same time, potentially. So it depends on your use case.
I think one thing that could come out of this is if anyone's listening, they could write a EIP standard for putting the data inside the data field. That would be nice. Yeah,
I mean, this is definitely one of those things that comes out of like Ethereum having less of a kind of payment-centric culture than a lot of the payment-focused blockchains that, there's relatively less people that use it for plain old consumer to merchant payments.
I mean, I can have a go at building that if you want.
Yeah.
Am I still?
Yeah. Do you want to make a comment, Tadge?
Audio working? Yes.
We're still.
Hopefully, I don't know. I'll turn off the camera. I don't know if I'm lagging or something. I would just say with the Coinbase thing specifically, what was interesting. I'm pretty sure Coinbase does not do this anymore, but I know that years ago they sort of were acting like Bitcoin was an account model, right? Where each person had this sort of withdrawal address, where whatever address you gave Coinbase that you wanted to withdraw to, they would first send it to sort of quote unquote your address, which Bitcoin controlled the private keys for, and then from there send it out to you. So that was a big aspect of they had sort of a weird custom software that was trying to treat the Bitcoin UTXO model more like a account model. And I definitely agree that the account model is much more intuitive, but I really like the UTXO model, having worked more with it, because it's much more sort of purpose built. There's definitely things you can't do with it, but for just what I think Bitcoin tries to do, it's really nice efficiency gain.
I have one more quick thing I'd like to throw in, which is that Vitalik mentioned the difficulty, the annoyance or cost of having to consolidate coins in the UTXO model, where if you receive a bunch of small payments and then the sort of the ambient network fee level goes up a certain amount, then you'll find that payments you received are no longer usable to you because they're in UTXOs whose value is less than the network fee required to spend them. And he mentioned how to avoid this. Basically, you combine multiple small UTXOs into one at times when network fees are lower. And I think as a user hearing that, that's maybe like a scary thing, right? This is something that you've never even heard of, and then suddenly your funds become inaccessible. And there's nothing you can do about it. And I should maybe mention that that's not really the case from a user perspective. Right now in Bitcoin, the minimum fee required to get into a block goes to zero, or whatever the denial of service lower limit is, every Sunday afternoon. For reasons of inefficiency, network fees tend to go up by quite a bit during bankers' hours during the week. They go down every evening, and every evening in New York. It's all New York centric for who knows what reason. And then they go down quite a bit on Saturday and even more on Sunday. And so for network security reasons, I hope that situation changes, because it is very bad that nobody's paying to secure the network on Sundays, because obviously attackers don't have to take weekends. But what that means is right now as a developer, you can have code that just always does consolidation on Sunday afternoons. And in the future, when hopefully that situation goes away, the whole ecosystem will be much more mature to a point where these kind of conversations will be like esoteric technical things that nobody has thought about in years, because there's like an off-the-shelf solution to all of them. I just wanted to throw that in there.
Cool. I can sort of move on the topic a bit so we don't, dive into, keep talking about, I don't know, gas limits or not gas limits, sorry, pricing. One thing I did want to bring up is basically the Bitcoin scripting language itself and what it's capable of. I think that's quite interesting. I was going to make a joke about how transactions are signed in Bitcoin, but I won't make that one now. I'll just move on to save time. So basically, Bitcoin scripts sort of like this dark art that no one really understands. You have to be a special wizard to write Bitcoin script. I remember trying to do it once or twice myself, and I really hated the experience. And I mean, potentially thousands of Bitcoins have been lost in the early days, pre-2014, just because of really bad scripts that people wrote. Most of these Bitcoin scripts and most transactions seem to rely on like three basic primitives. This coin can be spent if one or more parties have signed the transaction, a single sig or a multi-sig. This coin can be spent after time t. And coins can only be spent if a secret is revealed before time t. They seem to be the most primitive, the basic primitives that you get in a Bitcoin script. And so this is really a question for Tadge. So obviously, Tadge, you were involved in designing the Lightning channels, the Lightning network back in, I guess, 2014, 2015 now. And these were the basic three ingredients you had to build, the Lightning protocol. How did you find that? I normally find designing stuff in Bitcoin, like, punching it in the submission to get it to do what I want. I wonder what your experience was like doing that.
Yeah, it was difficult. It wasn't even the script, like, at least as of 2014, like, you couldn't really do the Lightning script because we didn't have op check lock time verify or op check sequence verify. So the time locks were only transaction based initially. And it was sort of like how, there were previous constructions that were much more limited because your channels had like a fixed duration, and you could only update a certain number of times. So part of it was looking at, okay, given this like system, how can we put in like a very minimal change to allow the Lightning network channels? The script itself, once you have that, I don't think it was that bad. Like, compared to everything else working on Lightning, you probably spend a day or two, tweaking the script and the opcodes. But compared to everything else, that was not really the issue at all. So it wasn't like, the writing the script is hard, but so many other things are much more involved, and like actually getting the opcodes and being able to use them.
Yeah, this sort of leads me to a question I also want to ask Andrew. So obviously the Bitcoin script is like a very tiny part of the overall protocol, and but obviously the script, like whatever you can encode on the blockchain, will influence the wider protocol what you build on top. So what do you think is the experience? Maybe Andrew wants to answer this first because I know he has some opinions on this based on what he's been building recently. Building protocols on top of Bitcoin scripts. You've got the script and it works, but now you need to do the multi-party work on top of it. Have you guys found that?
Yeah, it's funny that Tadge says, the script is such a small part of the protocol, everything is much harder. So sure, if you're somebody building the Lightning network, then maybe script is a small part of your complexity. But I would hope that ordinary users just trying to manage their coins wouldn't be dreaming in terms of Lightning network scale complexity. And in that case, I think for ordinary wallet developers, the script is actually very difficult to use. And it's funny to hear you characterize what script can do in terms of signatures and time locks and hash preimages, because that meme or that way of thinking about script is actually fairly recent. That comes out of a project I was doing with Peter Wola and Sanjit Kandlekar, starting in 2018, called Miniscript, which was a way to find a subset of script that was useful, could do a bunch of different things, but that also had a comprehensible user model. Because my experience directly trying to use script was pretty similar to Paddy's. I've probably dug into the Bitcoin script interpreter more than most people in the world. And even having studied it for several years, there's really a lot of weird sharp edges. It seems to me like it didn't have a clear purpose when it was designed. It wasn't like, we should think in terms of signatures and hash preimages and so forth. It's sort of a collection of different operators that seem to be stolen from Forth which is some old school like 1960s programming language that is basically like assembly, but like crumpled up in a dumb way. Yeah, you can quote me on that. It has a bunch of weird opcodes that were copied from an unrelated programming language called Forth. It had a bunch of arithmetic things in it that, as I think Paddy mentioned, was eventually disabled because their implementation had security issues. They would a lot of them would run into undefined behavior in C, or they would allocate unboundedly much memory under certain circumstances, or various awful things they would all do. The language paradigm is basically similar to EVM. It's a bunch of opcodes all in a row, right? You do this, you do that, you do this, you do that, and you're operating on bits and bytes. You're not thinking in terms of signatures, you're not thinking in terms of time, and as Tadge mentioned, in the original incarnation, until very late in the game, until 2014, 2015, we didn't even have opcodes that could work with times. You're just thinking in terms of bits and bytes, which is really not how, as a user, is really not how you're thinking about things. And so you find, as a person trying to use script, you run into this double whammy of, first of all, script itself is full of dark corners and weird sharp edges. And secondly, you have to translate your mental model of what you're trying to implement, right? Maybe you want like a 2 of 3 multi-signature with like a time-locked emergency clause or something like this. You have to translate that mental model into script itself. And the way Ethereum approaches that second issue of translating the mental model is in Ethereum you have these languages, you have Solidity and you have a Serpent, and maybe there are others now, but I think Solidity is sort of what everybody uses. And this is a language that looks similar to other more modern programming languages, and there are compilers that will translate that into EVM, which is similar to Bitcoin script, but had maybe clearer use cases in mind. So yes, script is very rough. So the origin of Miniscript, which I mentioned, and I'll try to be brief so we can move on, was trying to come up with something that would let users use Bitcoin script in the same way users can go ahead and use Solidity. And we had two limiting factors in designing this. One was that we were working with Bitcoin script, so simply can't do a lot of the stuff that EVM can do. So that was both tied our hands and also made our job a little bit easier. And the second thing is we were a bit scared of all of the issues in Solidity, both related to users working with a fully general programming language where maybe they would run into surprising interactions, especially related to like reentrancy and figuring out costs for various things. And also there have been issues in Solidity related to the compiler itself doing surprising things or buggy things. And what we wanted was a way that users were almost basically just using Bitcoin script itself. So the way that you compare what's on the blockchain to what the user readable version is, we wanted that to be like as thin a layer as we possibly could. So we came up with a scheme called Miniscript, where Miniscript is basically you build this tree, this graph, however you want to call it, of signature checks, of time locks, of hash checks. You put these into a tree where all your nodes are like ands and ors and like 5 of 7 of these and 2 of 3 of these and so forth. And then we have a way to serialize that tree directly into Bitcoin script opcodes. And you can also deserialize it and back. So the way that we think about script today is usually in these terms. Because when you're using Miniscript, you have a nice pretty picture. You've got this tree you can draw of your script and all your conditions. And if you're using script, well, hopefully you can deserialize your script into Miniscript. Because otherwise, you're in the dark forest of mysterious script behavior. And that situation kind of hasn't improved since ever. Bitcoin script itself is still quite difficult to work with directly and quite difficult to reason about directly.
Opcode separator. That's all I have to say.
Yeah, dark corners. There are dark corners everywhere.
Can I just ask like a good summary of that? So with Miniscript is the idea that instead of actually writing Bitcoin opcodes and dealing with the script itself, the idea is more that you outline the type of constraints that you care about. So maybe you want a multi-sig here where you want Alice involved to sign it. Or maybe there's another condition where you say Alice can then spend this coin after time T. And as a programmer, you just write these constraints and you don't really deal with the opcodes. And then everything just gets nicely packed up into a tree. And then you can just reveal one of the conditions and then spend the coins based on that condition. Is that a good way to summarize it?
I think so, yeah. And what's cool is I'm pretty sure you can do the same thing. I think you could take Miniscript and then serialize it into EVM as well. You'd have to come up with a serialization, but I don't think that would be difficult to do. I think you could get an intern to spend a couple afternoons on that. So the model is not just limited to Bitcoin script, but we were sort of we wound up coming into it both based on the limits of Bitcoin script and also the Bitcoin ethos of really trying to minimize the number of layers between what gets executed on the blockchain and what's in the user's head.
Yeah, Vitalik, did you want to comment on this? I've seen you unmute yourself a few times.
Yeah, and there's definitely a lot of things that got covered there, and I think one of the in general, right, like making a scripting language is hard, and so I definitely see why a lot of the opcodes got disabled very early on, right? Like one of the classes of bugs that's it takes quite a bit of thinking to weed out in the scripting language is what I call quadratic execution bugs. So this is basically where, like, if you have n worth of space in your script or in your execution time, you can create n things, and each of those n things take like n amount of work to do. And so n multiply by n, and so if a thing gets twice as big, it takes 4 times longer to execute. Maybe Tadge or Andrew could correct me on this, but I remember Bitcoin having, and perhaps still having, a quadratic execution issue where basically you generate a big transaction that has a whole bunch of different signatures, and for each signature you have to compute a separate hash by basically taking every input except for that input, and so you have these n hashes of n size, and so it's technically n squared, but like because Bitcoin has smaller block sizes, it only takes like something like 30 seconds to verify. Notice that
you just took my joke, Vitalik. That was the one I skipped over.
No, but like Ethereum basically, like historically, it's had lots of like similar issues, and there was this time in 2016 when and we had this attacker who, I don't know, probably on net was quite helpful to the ecosystem, like just systematically like went through every one of the issues in the protocol and just attacked them on mainnet, and ended up like almost shutting mainnet down. I mean, not quite shutting mainnet down. Like I think the Augur ICO happened during that time period, but like making it really hard to use for about 35 days. And we eventually had to hard fork to get around it. So it was tough, and there's definitely a lot of these security nuances, and you have to really explicitly think about gas costs, and Bitcoin has its equivalent of gas costs, because I think you have there's the block size and witness size limits. You have this I think SIGOPS limitations, was it some other things. So it's there's tough things that you have to think about, though the trade-off is that if you create a scripting language that's richer than there is some higher layer simplicity that you can get, right? So one of the, I think, benefits that you get on the Ethereum side is that the ability, what we call rich statefulness, of this ability to have these objects where objects have persistent addresses, and those objects can be modified and keep the same address. That's something that I've definitely heard even payment state channel developers appreciating. It's something where if you want to do something more complex, like one of these wallets where you can start a transaction, that transaction has a 24-hour waiting period. Within that 24-hour waiting period, you can cancel it and all of that. There's ways to do it if you add other opcodes in this model where basically every object that you have is a one-time use object, but it's still there's benefits where the mental model that you have of your wallet, and your wallet just stores things that map directly to a smart contract. So
yeah, you sort of picked up my next point as well, Vitalik. So let me just summarize all of this just before we jump into anything. So Bitcoin had this really weird signature bug, which was going to be one of my earlier jokes, where based on the number of coins you're spending, you'd have to do quadratic operations to verify that transaction. Now, in 2016, Bitcoin actually had a spam attack where someone was basically creating transactions that were fanning out and creating thousands of coins that were all dust. And eventually the Bitcoin miners went and fixed this. They reduced the state bloat by creating mega blocks to spend those coins. But those mega blocks took 10 minutes or more to verify. I don't actually remember the exact amount of time, just because that 1 megabyte transaction was huge. And because of this quadratic bug, the blocks just took forever to verify. And the hope, one of the big reasons for SigWit was not really for the block size increase. It was to fix that bug and to fix transaction malleability. So now in SigWit, we no longer have that weird quadratic bug anymore, which is really nice.
Well, no, but you have a way to make big transactions without the bug, but the old type of transaction can still be made, right?
Oh yeah, they're still there. Of course, the bug still exists. It's not gone. It's just polished over. Yeah, but okay. This gets on to my next point though, is to do with Bitcoin vaults. But before I get the Bitcoin vaults, was there's this ongoing joke in Bitcoin that you can do everything with multisig. You know, multisig is the ultimate smart contract. You don't need smart contracts at all. How true is that? Taz, Andrew, do one of you guys want to pick that up?
I guess, I don't know to what extent people are aware, but like discrete log contract is a kind of, and some of the stuff Andrew's worked on with Scriptless scripts, he could talk about what it's not exactly just multisig, but you can do quite a lot with just the signatures and the time locks. So you can, in discrete log contracts, you can have certain types of futures contracts or forward contracts with like an oracle that this gives you a price feed, and then you based on the oracle's price feed, someone wins money, someone loses money in sort of a lightning channel like structure. So there's quite a bit you can do with Bitcoin scripting. Obviously, it's much more challenging than Ethereum scripting, which is sort of built for do whatever you want. But it's kind of cool to be able to do these things and potentially much less traceable. Like if everything looks like a signature, and if there's something you can get to sort of fit into a signature, it's really nice.
Mm-hmm. Andrew, did you want to comment on it?
Yeah, sure. Going with the model we have of script, where it's signatures and hash locks and time locks. So Tadge mentioned some things that don't actually fit into those models that you can do with discrete log contracts, where the result is just a single signature. I have a toy called, not a toy, hopefully a real system called Scriptless Scripts, which lets you do hash pre-images using only signatures, and then having multiple signatures and stuff that we've known for quite a while, at least in theory, how to do multi-signatures and threshold signatures and stuff. Although certainly in practice, things get quite difficult when you try to actually implement that in an adversarial setting. The one big piece that's sort of missing is that there's not any way I would say is reasonable to do something resembling time locks using only signatures. So you find that when you're trying to do all sorts of cool things with just signatures, you find that actually you usually need a time lock backout condition, right? You want so that if too many of your parties just drop out and disappear, or they try to grief the protocol or whatever, that after a certain amount of time, everyone else can call their coins back. You need that in pretty much any protocol. And right now, the way that we know how to use signatures is basically you can't do it with just signatures. So you need some sort of scripting ability. So in SegWit v1, or Taproot, part of our design goal was that in the cooperative case, in the happy case for any protocol you design, you can get away with using just signatures. So we made sure that the happy case for Taproot spend looks like just a public key and some signatures. Okay, and then Taproot lets you commit to a script if you need a script. And the reason you would need a script in practice is typically to have some sort of time-locked backup clause. So if things go wrong, then you say, oh, haha, that public key that I told you, that was secretly a commitment to some other script. And then here's a script, and here we're going to execute it. The time lock's up, here's some more signatures, blah, 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 whatever. But I've going back to very early in this call when Vitalik said, like, worse is better. I think this script-to-script stuff is maybe like a real example of where worse is better might wind up killing us. And I hate to say that, but it's very difficult to work with scriptless scripts. I know there are a few people out there, including Tadge, I think, but also Pedro Marino Sanchez, who you should get on the show, Peter. That would be cool if you could get Pedro on here. Okay. Who are working on trying to build like a coherent protocol framework using scriptless scripts. But the current situation is basically, like when I was talking about how awful Bitcoin script is to use, well, imagine if every single script you wrote, you actually had to like write a publishable academic cryptography paper and like with mathematical proofs and get that through peer review. Like that's the level of difficulty, and like not even like simple papers. Like you can't even like ask a grad student to do it in a couple of weeks. Like half of these are really complicated, like multi-party protocols with like really complicated security models that are difficult to even describe. So yeah, you can do anything you want with just signatures. but the complexity blow up is unfortunately really big. And that trade-off may be reasonable for something like the Lightning Network, where like the script component is a small piece of the whole puzzle, and the script component never changes. So you have like one script that you use for every single channel.
I mean, I can try to summarize what you're basically saying as well. So scriptless scripts, and the point of a scriptless script is that so far it does the condition coins can only be spent if a secret is revealed. The secret being the discrete log in this case. And the idea there is that we want this condition to look indistinguishable from a normal signature. So you see a signature in the blockchain and you had no idea there was a script even involved. And Taproot's also basically trying to achieve the same thing. The idea in Taproot is that you can hide most of the scripts on the blockchain and you only reveal the script that you're going to spend later on. Is that a good way to summarize it?
Yeah, I think so. And it ties in, I guess, to what I said like very early on the call about trying to just minimize what you put on the chain, right? Mm-hmm. The end result is there's a key and there's a signature, and that's all that hits the chain. And the whole protocol, all the scripts and stuff, kind of are hidden behind the scenes amidst this more complicated protocol that's only amongst the actual counterparties and not amongst the blockchain validators.
Yeah, I would also say that like it's sort of hard mode to develop scripts and signatures this way. But if you get it to work, it's usable in other systems that have much more powerful scripting. So like you could do these kind of things in Ethereum because Ethereum certainly supports, checking signatures. And you also maybe get some of the benefits of it not being obvious what people are doing. So it's really important work either way. Although, yeah, for many things, it gets too complicated to make. You're not going to be able to have ERC20 tokens with scriptless scripts, right?
Yeah. Okay, I can move on. I can start moving on to a bit of Ethereum now, just so we speed up a little bit. So one thing I wanted to highlight in the Bitcoin world is one really cool feature that would be nice is a Bitcoin vault. The idea being there is that when I receive a coin on Bitcoin, it gets locked into my vault automatically. And then if someone tries to spend or steal my Bitcoin, there's this pending window of 24 hours where I could see someone trying to steal my Bitcoin and I could reverse the transaction. That's the basic idea of a Bitcoin vault. But so far today, to achieve that in Bitcoin is very difficult because they don't support this technique called covenants. So the way to achieve it in Bitcoin today is you send it to my address, my signing key is online, I have to pre-sign a transaction, keep that in local storage, and then delete my signing key. And that's not really ideal for a secure setup if you want Bitcoin vaults because all your signing keys are online for a limited period of time. Now in the Ethereum world, this is way easier to implement. I could probably write a smart contract within the next hour or two that would hopefully not be broken and would be able to do that. But hopefully will not be broken is the important bit because the EVM is very expressive and has a lot of very quirky bugs. Good examples are the DAO, that led to that hard fork that I think was it Vitalik, was it 20% of coins that were locked up in the DAO?
It was 12%, I think.
Okay, 12%. Yeah. So, that was written by the Ethereum developers back in 2016, and there was an unforeseen bug that no one except Andrew Miller was able to predict. He has a I told you so slide on one of his slides about this. And then later on, we had these wallet contracts by the Parity wallet, and that was hacked twice. The first time, I actually forget the damage in the hack, but that was a smart contract bug. The second bug for the Parity wallet was the wallet architecture, and it just wasn't deployed correctly. So this guy called DevOps199 came along. He set himself as the owner. He did self-destruct, and he destroyed everyone's Bitcoin or Ethereum and locked it up. So getting these smart contracts right is actually a tricky job in its own right because it's so expressive. And one thing I wanted to bring up were actually, I guess, security audits because they're very topical at the moment. I wanted to get a contract audited recently, and it was going to cost me $17,000 for a week, and I can't afford that, so I didn't get it audited. But what we're starting to see now is a lot of these yield farmers popping up. There's a new one called Burger today. There was one called Sushi last week. And they all test in production where they release the contract. There's always bugs in these contracts, but then the community goes and audit it afterwards. But Tadge, what's your take on that current trend? And also, you've also done some work with Viper, a language to try to get rid of some of the common bugs. So what do you think about both of those topics?
Yeah, and I think writing smart contracts safely is definitely a challenge, and it's definitely kind of not as easy as kind of just write a program and you're done, especially if you want to end up holding significant amounts of money. I definitely also think that the security situation has increased quite or improved quite considerably since 2016 and 2017. If you compare, like MakerDAO and the security process that they went through compared to the original DAO, there was much more work that was gone into auditing it. And the thing has millions of ETH, and so far it's been fine, surprisingly fine actually. In Uniswap, Uniswap isn't that complicated. It's definitely much less than a DAO. It's just a single contract, a couple hundred lines of code, and it's been fine. So a lot, and as far as wallets go, the Gnosis Safe wallet is like the standard that everyone uses, and that's, I think, even gone through formal verification. So there's it does seem like the contract writing environment is considerably safer than it was a few years ago, but at the same time, like there's definitely like this situation where kind of the capabilities of the system just kind of crash against the realities of human impatience. And, there's a lot of people who, like if you say, you instead of safely creating a contract system in a year, you can safely create it in a month. Like they're going to hear, instead of safely creating one in a month, I can unsafely create one in 3 days, and that's what they do. So that's. I definitely expect that the kind of DeFi yield farming ecosystem is going to get a reckoning of some kind at some point. I definitely expect there to be one of these bugs of some kind that leads to money either getting stuck or getting stolen in significant quantities at some point, and maybe. I'm definitely hoping that when that happens, it'll happen in a way that kind of scares people without actually being harmful to a really large extent. It's a challenge. Like it's the things that people are doing right now with all of these kind of yield and lockup contracts, like there's definitely things about them that scare me. Like even the thing that scares me is just like actively encouraging people to deposit high amounts of value into untested things. Like yield farming is almost a perfect storm of risk from that sense.
Vitalik, can I ask you something here? The world of exit scams is something people don't particularly like, but could somebody build one of these yield farming projects and write their own, let's say their own exit scam into the smart contract without anybody knowing and be able to steal funds from it?
Right. So what would happen is first of all, like when you write a contract, there is, I think, a community expectation that you have to publish the source code on Etherscan. And if you don't, then like a lot of people will yell about that. So then you have the solidity on Etherscan, and like you're going to see a bunch of people checking it and trying to audit it. And Ethereum definitely has this kind of sub-community of kind of volunteer, well, not quite volunteer, because they end up getting tens of thousands of dollars on Gitcoin because I know the community loves their work so much. But there's kind of auditors that and there's definitely people that kind of go through and try to check all of these systems, like basically just like give them quick emergency audits while they're online.
Who audits the auditors?
And I guess presumably the auditors kind of implicitly audit each other, and if someone misses something, then their word isn't taken kind of for as much in the future. But
can you have multiple people audit the same script? I mean,
totally, yeah.
Okay.
That's what usually happens.
Okay. Next up, I talked to Andrew, Tadge, Vitalik, and Patrick more about the technical differences between Bitcoin and ETH. But before that, I have a message from my amazing sponsors. So firstly, let's talk about Kraken, my favorite place for buying and selling Bitcoin. They put the power in your hands to trade Bitcoin. and they are consistently rated the best and most secure cryptocurrency exchange. And if you want to start trading Bitcoin, well, they have all the tools that you could possibly need. Whatever your experience, you can head over to kraken.com, as it could not be easier to sign up and start trading Bitcoin. They also have a beautiful mobile-first app, so you can buy Bitcoin on the go. And with their margin trading, futures, and OTC desk, Kraken has every option covered for you. There is no better place to trade Bitcoin. You can find out more at kraken.com or download the app, which is available for the iPhone and Android. Just search for Kraken Pro, which is KrakenPro. Also, let's talk about BlockFi, who are the future of Bitcoin and financial services. With BlockFi, you can open up an interest account and start earning on your Bitcoin. I am a customer. I've been a customer all year, and I've just made over 1 Bitcoin in interest, which is super cool. Also, using your Bitcoin as collateral, you can take out a USD loan, and you can fund your BlockFi account directly from your Bitcoin wallet. And with their mobile app, you can now access all of their services on the go. With so much more coming this year, the company is definitely going to smash it again. And if you are interested in checking out BlockFi, firstly, I recommend you do your own research, then head over to blockfi.com, which is blockfi.com.
One thing I also wanted to bring up was to do with, one of the big features of Bitcoin was multisig. You know, everyone loves multisig. Multisig is the saving grace of Bitcoin. In Ethereum, multisig isn't as popular as I'm aware, and that's mostly because you need a smart contract wallet to implement multisig. And there's protocol, different ways to do that, like Genosis, Safe, etc., have their own multisig setup. Do you feel like, because of what happened with Parity Wallet and the fact that they got hacked twice and they lost so much money, has this impacted people's willingness to use wallet contracts? Like, for example, would you lock up money in a wallet contract today, and they actually use, a nice multi-sig setup?
So the Ethereum Foundation, still has the bulk of its coins in the same wallet that it had for 5 years, and it definitely has not made the choice to move to a single sig. So I definitely think that it would be wrong to kind of take the Parity Wallet experience and kind of transplant that into multi-sig wallets in general. Like, as I mentioned, Gnosis Safe has had a lot of verifications and of attention on it. But I think, it definitely is true that the parity situation did spook people off of multisig for some time. But at the same time, the smart contract security issues are not the only reason why multisig is having a hard time getting Ethereum adoption. There's a lot of these subtler issues, and this is maybe one of the Ethereum equivalents to the stupid stuff in Bitcoin, like the zero at the start of the multisig that you mentioned. Basically, the problem that Ethereum has is that it tries hard to be this general purpose and abstract thing. But the one specific part of the system that is basically what kind of account can be a top level account, so what kind of account can basically initiate a transaction and be directly paying for transaction fees. There's only one type of thing that's allowed, which is just a single signature ECDSA account, right? What we call EOAs, externally owned accounts. And we have some EIPs, and I've been heavily involved in pushing them. Account abstraction is the name for this, that allow you to have smart contracts be at the top and smart contracts be paying for transactions. But until we have that, the problem is basically that if you have a smart contract wallet, then you would actually need to have 2 addresses. One address is a smart contract. The other address is a single signature address, where the single signature address holds the ETH that you use to pay for transaction fees. And so your transaction initiates in the single sig, and then it calls into the multi-sig, and then the multi-sig verifies the other signatures, and then it forwards the call along. And if you don't want to do that, then you could use one of these layer 2 gas market things where someone else acts as the real layer for you, but then you have to pay for an entire extra transaction. So there are these annoying complexities that we definitely didn't think through well enough at the time when we were creating a protocol. And now we're finally starting to take moves to improve the situation. But that definitely, I think, has been, and not completely preventing, but definitely hampering adoption of multisigs and some of the other smart things like social recovery, for example, that I advocate from actually being used more.
Yeah, I can definitely agree that the fact that the person who's authorizing the command and who's paying for the transaction is the biggest pain in the ass in Ethereum that I've had in the past year. Because we're building a third-party relay called Any.Sender, and that's the biggest issue we run into at the moment, and it's driving me crazy. So we have to tell everyone these wallet contracts. I just want to ask one more question, and then we'll move on to the future of scalability, because I think that'll be quite interesting. And this is really just to do with the birth of Ethereum and now in hindsight. So I went on the original Ethereum.org website to see what was promised, because actually I didn't get into Ethereum until about 2016, so I wasn't there. And I was there in 2014. I just wasn't paying attention. And so what it says on the website is, when Ethereum was launched, it was called a decentralized and scalable world computer. Oh, actually, that's me reading it. Sorry. Now, what it said on the website was, Ethereum can be used to codify, decentralize, secure, and trade just about anything. Voting, domain names, financial exchanges, crowdfunding, company governance, contracts, and agreements of most kinds. Intellectual property, and even smart property thanks to hardware integration. And I took that from the Ethereum.org website, from the web archive. So hopefully there's some integrity to what that statement was and hasn't been changed in hindsight. Do you think anything based on that and how Ethereum was advertised back in 2014, was anything misleading? Do you think it's held that goal? And in hindsight, would you change anything about that?
Mm-hmm. And I think the world computer metaphor is one of those things that was kind of badly chosen to some extent, right? And I think the intention of the world computer metaphor would be that this is a special kind of computer that can be accessed by and used by anyone in the world, and it is a special purpose tool, and the transactions on it are going to be kind of expensive, and you can only do a little bit of computation on it. But people took it to mean, a computer powerful enough to meet the world's needs of computing, which it obviously isn't. And even with hyperscalable ETH2 and rollups, it's never going to be anywhere come within orders of magnitude of being able to run the entire world's AWS stuff, right? So as far as that list of applications, people are using it for various financial applications. People definitely have made projects use it for smart property. People are using it for domain names. And in terms of scalability, I think we've been fairly clear since the beginning that scalability is going to depend on future things like, either sharding or layer 2 protocols. And those are things that we've been really actively talking about in pretty much any Ethereum kind of discussion since even 2014. Though the thing that I think you can say fairly is that we did underestimate the amount of time until those technologies would be ready. But in terms of just fundamental feasibility, we've definitely come quite far. And now we're in the earlier phases of ETH2 are in test nets, and rollups which actually would provide up 2 orders of magnitude of scalability for a lot of things. Actually, are months away from production. So.
Awesome.
Yeah, and I think timing was probably the main issue, where expectations in reality ended up being relatively disjoint from each other.
Yeah, Peter, did you want to say anything before I move on, or?
No, we covered world computer and changing narratives. I know some Bitcoin people that really frustrates them. Look, I don't use Ethereum, but I understand that things pivot, things change in technology. It's the way it is. That's never been something that's fussed me.
Okay, so I guess we'll just move on to scalability now and the future of both of the networks. There's really 2 ways I've tried to categorize scalability in 2 ways to keep it very simple. The first way is, given a set of hardware that we have, can we increase the throughput of the network? I.e., if it takes me 20 hours to verify the blockchain, can we reduce that to 10 hours? That's a constant scalability. Can we just simply improve the software to be more efficient? And the other one is, can we just reduce the computational load? Do we have to send every transaction to the network? Does the network need to process this entire smart contract? What does the network really have to do in order to keep everything secure? So I'm going to touch upon the first category briefly, and then we'll dive into the second one a bit more.
Are these both points for both networks?
Exactly.
Yeah, let's go with Bitcoin first. Just have an Ethereum break.
Awesome. Yeah. So I was going to I always have this joke about Bitcoin developers hopefully no one gets offended by this. But I always compare them to assembly programmers who want to understand, to the best of their ability, every little detail about how the implementation works, straight down to how many SIGs can you have a multi-sig, how many SIG ops are allowed, what's the exact microsecond to verify an ECDSA signature. And that's actually some of Andrew's work there. So back in, I believe, 2016, he was working on SEP 256K1, which is an implementation on how to verify signatures that was really way faster than what Satoshi was using before. Andrew, do you want to talk about some of that work? Why is that important to speed up verification of the signatures?
Yeah. So what Satoshi was using was actually just OpenSSL. He was using just these off-the-shelf, kind of fairly general-purpose crypto libraries. Not general purpose, but signature libraries that were designed to work with a variety of elliptic curves and use various slightly tweaked algorithms, and they weren't really super optimized. And so Peter Wolla, actually, I think in 2014, no, earlier than that, it must have been, but that 2012? I don't know, a long time ago, developed the libsecp 256K1 library that you mentioned, which I did a fair bit of work on in 2016. I'm still a maintainer, but I really arguably shouldn't be because I'm not so active on it these days, which pre-implements the low-level signature protocol, signing and verification that's used for Bitcoin script, and which actually is also used for Ethereum. I think all of the major Ethereum clients eventually use libsecp for doing signature verification. This is a very widespread library. Like almost all Bitcoin software, almost all Ethereum software winds up using this because it's really hyper optimized. And so to your joke about Bitcoin developers being obsessed with these nitty gritty details and stuff, I mean that is kind of a fair joke. As you mentioned, there's this whole other category of optimization. And there are people in the Bitcoin world working on Lightning and working on other scalability things, but certainly the people doing like major protocol changes and who are like working on Bitcoin Core, especially the like consensus part and the crypto parts of Bitcoin Core, yeah, they're just like they really obsess over the smallest of details. And actually, a few of them over the years, a bunch of them have worked for me on my team. And in a for-profit company setting, this can be extremely frustrating sometimes. They'll just be really getting into the weeds on like specific stuff, and I'm like, guys, we need to fucking deliver. Like, please, let's just move on, and then we'll go back and forth on some specific detail for weeks on end. So yeah, I mean, your joke, it made me smile. Certainly, I think it's fair.
Tadge, I've got a question for you as well. So this is also related to I can't actually pronounce the protocol. UTREEXO.
UTREEXO. There's a tree of them.
Yeah, basically accumulators. So the idea is that I can validate transactions while keeping around everything that I need. I think it's the UTREEXO set. You don't need to keep that around anymore. Yes. You want to talk about a bit more about that and how that?
Sure. Yeah, and I guess there's very similar research done on the Ethereum side. So maybe we're talking about that, but I guess in Ethereum they call it stateless clients. And that name has sort of bugged me because it's like, well, there's still a state. It's just smaller. But anyway, so the similar idea. So the idea of UTREEXO is instead of keeping the whole state, just keep this sort of root hash of it, which, Ethereum has had, right? Ethereum has this state tree and, every block commits to the root hash. And people have been talking about that kind of idea in Bitcoin as well for years and years and years of like, hey, what if you have UTXO commitments? What if you have a hash of the UTXO set and like stick that in the block header or something? The nice part about UTREEXO is it uses a hash-based accumulator with some really nice scalability properties so that the proofs are not too big and the proofs sort of stack alongside each other. And there's a bunch of optimizations so that we can exploit a lot of the spending patterns of Bitcoin. And so there's a sort of fun chart I like in the paper where it shows sort of the popular the lifetimes of a Bitcoin UTXO, right? A Bitcoin UTXO is created as an output, and then at some point it gets destroyed as an input. And how long does it live? And so the most popular lifetime for a UTXO is 0. Like the most popular is that a UTXO is created and destroyed later in that same block. So it's like, well, why even? You don't even need proofs for that, right? So a full node doesn't even have to touch the database for that, and it's sort of this power law going down. So we can exploit that fact, and you can get pretty small proofs, despite it being, in theory, it's linear proof size, and which is different than a lot of the more mathematically complex accumulators. But it's kind of a simple version that maybe initially some people would say, oh, it's too simple. It's not. But if you actually look at it and all the optimizations, it ends up being a 30% data download overhead to do these really cool proofs, and actually gets really fast because you don't have to deal with level DB, which is both in Ethereum's case and Bitcoin's case in many ways the big bottleneck. So it's a nice way to sort of not have to worry about databases. And those databases do grow unbounded in both Ethereum and Bitcoin's case. Like while there's block size limits or gas limits, or maybe I shouldn't speak for Ethereum, but I know in Bitcoin's case, there's no real definite bound on the UTXO set. It could get huge. It doesn't. It's about 70 million right now. But if someone really was dedicated and wanted to attack, maybe I shouldn't say this, they could really make it a lot bigger because it sort of treads water right now.
Right now, in Ethereum, there's no in-protocol hard limit on the state size. And right now, I think it's, I forget, it's somewhere in the hundreds of millions of objects. So I wants to say around 400 million, but it depends on what you count and are you counting account storage slots, hashes, and so forth. But it's in that ballpark.
Yeah, so it's a bit bigger than Bitcoin's, but it's still same order of magnitude, and it's not not like exponentially bigger or anything like that. So, but in both cases, it is a long-term work. I mean, in Ethereum, I guess you're thinking more of ETH2, but in Bitcoin, it's sort of this is a long-term scalability issue. If while you historic blocks, once you verified them, you can't really get rid of the current state if you want to keep validating. And so that's what the UTREEXO idea is. That, okay, you now with this, you can get rid of the current state. And now the only downside is you need to accept these proofs. And some nodes on the network have to be bridge nodes. And so a lot of the work was, how do you make it easy to run a bridge node? So someone can run a bridge node on a regular old laptop in order to let other people run nodes on much smaller computers.
Just to bring us back to maybe a more basic audience who aren't highly technical, what the state actually is just everyone's balance on the network. So if I run a Bitcoin Core on my laptop, I don't want to keep around, everyone's balance on my laptop at all times, especially if someone hasn't spent their coins in 6 years because they're hardcore hodlers. So what you could do is use this accumulator to store a little bit of information. And then every time they go to spend their coins, they provide proof that they still own these coins and they're still valid. And that's the whole point of it.
Yeah, philosophically, it's kind of nice because right now the model is, you do store everyone else's coins on your computer, and it's kind of annoying. And it would be better if it's sort of the responsibility of the people who own those coins. You have to keep track of your private keys. And in this case, maybe you also have to keep a proof that your coins exist so that you can sort of prove they exist to everyone else when you're spending. That's not really part of a lot of these models because it sort of conflicts with previous node. If you're starting Bitcoin from scratch, maybe you could do it that way and it would be really scalable and really cool. But because it's so hard to change Bitcoin, you kind of need these nodes to sort of bridge the old and new softwares. Maybe someday you could get rid of the old version, but probably not for any time soon.
Yeah, and I think what's really cool to highlight, and this is why I brought this up, is that while Bitcoin lacks any substantial upgrade as features, it's not like the scripting language is being improved. They're not really adding new features to Bitcoin. A lot of these changes are node policy changes. You can change your local node, and you don't need to tell the rest of the network you're doing this, but you can just work on making that actual client way more efficient for verifying transactions. So you're not changing the protocol, you're just changing the software, and anyone can do that locally in their computer. Now, what I normally find in the Ethereum world is that a lot of the focus is on changing the protocol and not necessarily the software. I always get the impression that the software is sort of just staying alive and, keeping its head above water. And a lot of the focus, at least all of the vocal points, is not really about the changes to the software itself to make it more efficient. So maybe, Vitalik, you can comment on that more. Is that a fair reflection? Yeah. Is that wrong?
Sure. So I think my mindset towards scaling is that, there's scaling techniques to get you 3x, and there's scaling techniques to get you 100x. And so obviously you should spend most of your time on the 100x. And so that's why kind of our mental effort tends to go toward like sharding and L2s and so forth. But I mean, at the same time, there has been like improvements to clients, right? And you can even see this on Etherscan, right? Like if you go to Etherscan and you look at historical uncle rates, I think it's etherscan.io/chart/uncles, then like you can see how in 2017, when we started to see substantial usage, the uncle rates went really high. And then sometime in 2018 to 2019, the uncle rates just dropped right back down to about 7%, like almost the same as what we had when we had empty blocks. But blocks were still full, right? And what happened there actually was client improvements, right? It was improvements to propagation. Like one of the clients, I think, like actually implemented a thing where you propagate a block after you verify the proof of work, but before you verify everything else. There have been improvements in block processing time. There have been improvements to databases. Like I think a couple of months back, Geth had something that reduced its data storage amounts by like something like 30% or so. There have been fixes to bugs, obviously, like as I mentioned, in 2016, we had this like huge marathon of basically being forced to solve all of the quadratic execution attacks in Ethereum. So like both things happen. And it could also just be an artifact of the fact that like for whatever contingent cultural reasons, researchers are louder than developers, that like while both strands of hard work are happening, people hear more about one rather than the other. But again, we've been trying to kind of balance that out recently, right? And like we've been seeing on the Ethereum blog, but there's work on kind of what we call the ETH 1.x initiative, and some of that is protocol changes, but a lot of that is also client changes. So I guess, as Andrew mentioned, we have work happening on stateless clients, which, but it's not necessarily fully stateless. Sometimes it's also partially stateless, like where instead of like having the entire state targeting nodes, having like say a few gigabytes of state and relying on proofs for everything else. So those things are all kind of happening, and they're happening in parallel. Which is definitely something that's sometimes hard to get across, right? Like, it's not a matter of like, oh, it's the choice of one or the other. It's like, no, you do this thing and you do the other thing.
Awesome. So now what I'll do is I'm going to move on to the other side of scalability, and even this can be categorized down to two things. So the question is, how can we reduce the computational load on the network? The first approach is fancy cryptography. One of the ironies in cryptography research is that cryptographers mostly focused on privacy for the past 20 years. And now a lot of these SNARKs are evolving, and Zcash is a SNARK for privacy. But actually, SNARKs are great as a scalability solution. They allow you to provide a very small piece of information that's quick to verify. But actually, in the background, there was loads of computation that was done. And the other approach is just to take everything off-chain altogether as much as you can. So, Alice and Bob does, like a Lightning channel, Alice and Bob does the payments, and they just send the final settlement to Bitcoin. In this case, they just don't send it to the network unless they have to. So let's talk about fancy cryptography a little bit. And we're just going to keep this quite brief because fancy cryptography, you can go down a deep rabbit hole, and I don't think people really want to go into a deep rabbit hole about fancy cryptography. So one question is, why is fancy cryptography like SNARKs better than just improving the software? What is the big difference there? Does someone want to summarize that for us?
Yeah, and I think like fancy cryptography basically provides the 100x that I talked about, right? Like the reason I think why this big move toward general purpose zero knowledge proofs that we've been seeing over the last decade has been so powerful, right, is that you can kind of invent the primitive once, and then once the primitive is invented, then people can just go and use it for whatever things kind of much more quickly, right? Because it's general purpose, and so it's not about creating a new protocol. It's about just like applying an existing protocol with a slightly different circuit or whatever. So the reason why it's 100x is basically because you can generate these proofs where you perform a one-time effort to make a proof that says like all of these statements about all of these transactions are valid. And then you publish it to the chain, but then verifying that proof becomes this very efficient, kind of a quick operation that is takes a fairly small amount of time, almost regardless of how much information it ends up proving. like ZK rollups are one of these scalability strategies that rely on the fancy cryptography. So the idea is basically that it's kind of like this hybrid between layer 2 and layer 1 in some ways, right? You don't take everything off chain. You still have like a few bytes of data. I think it's about like 16 bytes of data on chain for every transaction. But then you also, instead of providing all the signatures and doing all the computation, directly verifying them on chain, you just have a proof that says, I know about signatures, and I have personally run the computation that says if you take this previous Merkle hash of the state and you apply these transactions, then you get this other Merkle hash. And I know this, and I've proven this, and then here's a proof, and you can just verify this proof that proves that, Nick, I've run this computation that's verified this entire whole bunch of stuff, right? So it's very powerful. It also gets into one of the kind of trade-offs that I think we see a lot of the time, where the fancier cryptography, like this also applies to kind of BLS signatures versus Schnorr, for example, right? Like the cryptography that's fancier and relies on kind of harder assumptions and is much more challenging at the lower levels often ends up presenting a much simpler and a kind of more easy to use black box at the higher levels, right? So you're kind of taking you're trading off complexity on one side for enough complexity on the other side. But so on the one hand, yes, these SNARK protocols are fairly tricky and complicated, but on the other hand, like once they're there and once you turn them into libraries and you have Socrates and Circom and so forth, then like you can just go and use that, and like developers that don't even understand the nuances of SNARKs can go and like build privacy preserving things like Tornado Cache and scalability, things like loop ring and so forth.
Yeah, I can pick up on that. So there was two real points that were made there. One was about rollup, and I want to cover rollup in about 2 or 3 questions. That's sort of like layer 2 in a way. The second one was the assumptions for SNARKs. SNARKs are very complicated. They're fancy cryptography, and they add in additional assumptions that people may or may not be comfortable with. So this is what I want to ask Andrew for now is Andrew worked on bulletproofs, which is another SNARK. It's now implemented in Monero. It's inside Liquid Network as well. And that was also really focused on privacy, so you can have, privacy preserving transactions on these different blockchains. But I just want to get your impression, Andrew. So why is bulletproofs not in Bitcoin yet? Will it ever? I mean, we're still struggling to get Schnorr into Bitcoin. I asked in Bitcoin Wizards back in 2014, when Schnorr going to get in, and I was told within a few months, and it's now 6 years later, and it's still not in. What's holding up Schnorr? Actually, that might even be first. Let's talk about that first. What's holding up Schnorr? Because I know you have some good answers around that. Schnorr is a very simple signature scheme. You guys are building really cool stuff on top that aggregate signatures into one big signature. What's the hold up? What are the problems you've run into with that?
Yeah, that's a great question. I'll try to summarize it fairly quickly. So we were talking about Schnorr, as you say, like 6 years ago. We first encountered it. It looked like it was a much simpler signature scheme. It had it was provably secure and a much saner model than ECDSA can be proven secure in. It appeared to be a lot more efficient. To verify Schnorr signatures, you don't need to do an operation that's called a modular inversion that you do need to do to verify ECDSA signatures. And what happened, actually, a lot of the initial delays, believe it or not, is that we realized we found better ECDSA verification algorithms, and Schnorr actually seemed like less of a pressing thing for a little while. It seemed like all these efficiency benefits that we thought we would get, we kind of weren't going to get. And these kind of philosophical provable security benefits, I mean, sure, but ECDSA has been used in the wild since 1990, and I think in practice, everybody's kind of comfortable with ECDSA. And then the other big benefit of Schnorr was that you could do multi-signatures with it very efficiently. And by multi-signatures here, I mean a specific form of multi-signature where you have multiple parties who can combine to produce a single key that represents all of them, and then they can interactively produce signatures with that key so that all of them need to participate to sign a message. But what the blockchain sees is just one key, one signature. There's sort of an obvious way, if you naively look at the Schnorr verification algorithm, to do this, where you take the elliptic curve points representing everyone's keys, you add them together in the sense of adding elliptic curves, and then everybody kind of like does the signature signing protocol together. Like everybody does the first half of the protocol, they add together their components, and then do the second half, and then they add together their components of that, and then you just take these sums. Everything's just sums, so it's so simple. And we ran into a series of problems with this. I guess like two categories of problems with this. One was that we realized that if Schnorr signatures, if we use the Schnorr signature as described in the Schnorr paper, where we didn't commit to the public key, there are certain weird Bitcoin things that are weird cryptocurrency things that we might want to do that would suddenly become insecure. So there is this worry about needing to commit to this public key, and there's this, I guess, trade-off between committing to the public key and then deviating from standards that were out there, and not committing to the public key and then having this kind of fragility that might cause problems with wider crypto systems. The bigger issue that we were having with Schnorr signatures, though, was that to do this multi-signature scheme, we ran into a lot of trouble. The scheme I just described, where you just add things together, that's just woefully insecure. It's very easy to break that. So we came up, Peter Willa and Greg Maxwell and I came up with this different, fancier scheme that we thought would be secure, that would eliminate a bunch of these attacks, where basically everybody's public key, we would re-randomize it in a certain way. You would take the key, you would hash it, and then multiply the key by the hash, and then that would just like kill any structure in the key, and then you couldn't use it to do these structured key attacks. It turned out that's also broken. There's something called Wagner's algorithm out there that can be used to break this quite efficiently. So then we came up with another scheme that, and actually we submitted this to oh no, what conference was it? Maybe Financial Crypto or something. It got rejected by a reviewer who was like, "Hey, you didn't cite. So first of all, your proof sucks," which is sucked because it turned out it was insecure. Secondly, why didn't you cite this 2006 paper by Belair and by Mahir Belair and Greg Nevin? So you look at this 2006 paper, and it does something like complementary but different from what we were doing with multi-signatures. It gave us a way to take a whole bunch of different public keys and get a single signature, where instead of collapsing the keys into one, you still have separate keys, but you get one signature. And so that is something that we now call signature aggregation. So then we went on this like long, like I guess it was over a year, like detour, thinking about signature aggregation versus what we now call key aggregation, and trying to separate those two and figure out which of those two things we actually wanted in Bitcoin, what was going to provide the most bang for the buck, what was going to be the most efficient, and then also what's going to minimize bike shedding, what can we come up with a coherent proposal for.
Andrew, just before you continue, can I try to separate what that means, just in case people get into that discussion? So like, the original goal was that you had 10 parties, they all want to do a signature together, you want to combine those signatures, and then they authorize the transaction. Where I think what you mean by signature aggregation was the second thing you just, like, basically in the story, this is the point where you just discovered it, is to take any one signature and just combine them all together. Is that correct? Or
yeah, that's correct. Yeah. So the difference, I guess, an important difference there is when we're talking about key aggregation, we're thinking about a bunch of people who all own like a single coin, and they want to have that coin like be controlled by a joint key that represents all of them. When we talk about signature aggregation, maybe there are multiple people with multiple coins, like all doing their own thing, but we want to be able to somehow collapse all of their signatures into one. So for a little while, we were super excited about signature aggregation. We were like, actually, this is a more efficient thing. I mean, there are more signatures than keys on the chain. That's a weird statement, and I'm not going to justify it, but we really want to collapse signatures together. And collapsing keys together is maybe something that's less of a priority, or something that we can do like a different protocol, or I don't know. But then when we started trying to design an actual protocol for signature aggregation, we ran into a whole bunch of weird interactions with other stuff. It would change the transaction verification model in Bitcoin Core and another Bitcoin verification software, where rather than a transaction being valid if every input is valid, suddenly there's like this weird interplay between all of the different inputs. It would compromise our ability to soft fork new features into Bitcoin, because when you are deciding how to verify an aggregate signature, you need to see some input data from each of the unaggregated signatures as a verifier. You need not as much, but you need to see a little bit. And then most of the soft fork mechanism we had in mind might actually change which signatures were available to different verifiers. So suddenly things that used to be soft forks would become hard forks, and people were upset about that. And it was going to force us to change our thinking about what different fork mechanism might look like. There were bad interactions with blind signatures. There were bad interactions with some other like weird signature protocols, and it really just kind of blew up in our faces complexity-wise. So we kind of set that aside and then went back to looking at just key aggregation. So we came up with this new scheme called Multisig, which basically provides both key. It provides key aggregation. It also provides signature aggregation. And we thought maybe, how do I want to summarize our thinking? We went back to just looking at key aggregation, saying that let's just try to have multiple parties who all produce an aggregate key. And I think actually the reason that we really started looking at that was we came up with Taproot. And I might be getting the history in the wrong order here, but this is all still a long time ago. I'm not even yet to the present. But when we designed Taproot, we had this protocol, we submitted this. I think it even passed peer review. I think it was fairly far along in the publication process, and we kind of got blindsided. A few different authors, Ford, Nevin, two others who I'm blanking on, published a paper showing not only that our Multisig preprint was insecure, but that it was impossible to prove any such scheme secure using the techniques we were using. It was kind of a ridiculous proof. It wasn't like our paper was wrong. It was our paper couldn't possibly be right, which is a very...
Wow.
Yeah, it was kind of funny. I was kind of like blindsided. That's not the kind of rejection you want to get, right? You don't want to like hear you're wrong. You don't want to hear you're wrong. You certainly don't want to hear like it's impossible for you to be right. It's like I have a proof that you're wrong. So then we had to modify. There was actually a fairly straightforward modification to the protocol. We added an extra round to the protocol. It became 3 rounds instead of 2, and then we were able to get to the proof to go through. And we were kind of it kind of freaked us out that we had written up this proof and none of us had noticed this mistake in our proof. Not only that, but there were multiple other papers that had been published, like going back like 20 years, and these other papers had like the same mistake in them. So actually there were a bunch of different protocols that were knocked out by the same paper. So then we went back, and then there was this whole thing of fixing the protocol and building our confidence that we were able to design secure multi-signatures after all backup. And meanwhile, of course, we're getting a snark from folks on Twitter and from people just coming saying like, Schnorr invented this scheme in 1990, but you're talking about putting it into Bitcoin in like 2013.
That sounds like me.
Right? Yeah. I mean, like, guys, like, come on, this is a joke, okay? Like, it's so simple. Like, you can fit a Schnorr signature. You can fit the equation onto like, I don't know. It's just, you can just say it. It's S equals K plus XE. Like that's it. How hard is that? It's one equation. And so we had that difficulty. And then when we started actually trying to implement the multi-signature stuff, we ran into other issues related to communication between the different signers. So Multisig itself actually isn't too bad in this respect. But when you try to do threshold signatures, you start getting into like really complicated things where you need like private communication channels between parties. You need like reliable broadcast channels between parties. You have to think about authentication. You have to figure out how are you talking to different people? How are you assuring that different people are receiving the same data? Blah, 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 blah. So we have some protocol difficulties with this stuff. Meanwhile, on the Taproot implementation front, because we landed on Taproot as like the way to get Schnorr signatures into Bitcoin. Like it's really quite a compact, simple protocol that doesn't have a lot of surface area to be bike shedding. Meanwhile, on the Taproot front, we're implementing that. We found, and here's like classic Bitcoin hyper-optimization, we found that in some cases, like fairly normal wallet transactions might be 1 byte larger in Taproot than they would otherwise be because our keys... 1 byte, yeah. Because our keys are 33 bytes in SecP256K1, And otherwise, we might be able to use like a 32-byte hash or something. I don't remember exactly under what circumstances you wind up comparing a hash to a key, but that's the deal. And so we thought, okay, let's compress the keys to 32 bytes. And then we spent forever doing that. And then there are multiple ways that you could do that. And eventually we settled on one. And I don't know. It's just been a whole thing.
I mean, maybe I can summarize this. Just
okay.
Because I guess it's like a long-winded story to say. It's really hard. Schnorr looks easy, but even that's hard. And I guess that was sort of Vitalik's original point, was that, because Schnorr has a very basic assumption that's this discrete log, one question I wanted to ask was, if you use something like BLS with pairings, you sort of get a lot of this just out of the box. So what's like the motivation to go down the Schnorr route and really pursue these new protocols versus adding in a pairing assumption and just taking BLS out of the box, which I guess Ethereum would do. What Ethereum did do.
Paddy, you can't keep calling it Schnorr.
Oh, Schnorr. I can't pronounce it.
It's Schnorr. You call it Schnorr. Come on, man.
Apologies.
So one reason is that I think historically we did actually expect Schnorr would be significantly simpler. Although now we know, now that we've seen all of these issues, and you're right, almost all of these issues, you run into them and you're like, oh, BLS would have solved this, because BLS doesn't involve any randomness. The keys are automatically aggregatable. The signatures are automatically aggregatable. There's a lot of nice simplicity that you get. But there are... So first off, as you say, there are a bunch of concerns about the pairing. So if we introduced a pairing assumption, so I guess for the audience, a pairing assumption is a cryptographic assumption. It's some computational problem that needs to be very difficult, otherwise the signature scheme is insecure. And this is just how you do cryptography. Like every single crypto system that you think about, there's some underlying hard problem that we've thrown, like 10 or 20 or 50 years of research at trying to do efficiently. We can't figure out how to do it efficiently, and then we just assume it's impossible and design crypto systems assuming that it's impossible. So in Bitcoin, we have like these very, very simple standard assumptions. The elliptic curve discrete log problem is hard, and the random oracle model is a compact way to say it. Pairings would introduce a new one. So there is some suspicion about pairings, because pairings are relatively new. I think the BLS paper was it 2006 or was it 98? I'm blanking on.
Pairings definitely started to exist in the 90s, and I think they were originally introduced in the context of being attacks on elliptic curves, right?
Yes, that's right. Yeah. So that was in the 90s, and then the BLS paper was the first kind of positive use of pairings. So pairings are a bit younger. I guess 10 years younger than more standard elliptic curve assumptions. They came into being as a method of attack on elliptic curve, on existing elliptic curve schemes, which I think put a bad taste in a lot of people's mouths. Like this is some weird, surprising algebraic trick that breaks things. This is a breaking thing. It's a bad thing because it breaks stuff. I really do think there's a subconscious aversion to pairings for that reason, but also because it's younger, and pairings have not really been used in production systems the way that elliptic curve signatures have, the way that ECDSA has. I'm not aware of any major system with any real money or any large number of users that uses BLS that isn't part of very recent, the last 2 or 3 years, cryptocurrency kind of stuff. And even then, I'm not sure that there's anything that's just big and out there. So there's suspicion of these pairing assumptions because they haven't been tested in real life. And then there's another category of suspicions related to pairing software not being as mature, and pairing software not being production crypto libraries that do pairings that are out there and that have been battle tested and so forth, that will provide constant time signing, or that will just have the kind of QA cycles that we've had on something like libsecp, which is very widely used, or even that we've had on OpenSSL, which has certainly had its fair share of problems, but it has been out there for 30 years, and a lot of people use it. And some people look at it. So Bitcoin has a real aversion to changing its security model, ever. And this particular change is one that really I personally wouldn't be so comfortable with. And then there's also this kind of like common knowledge issue where like I think that the community wouldn't like it, so I'm not going to bother trying to propose it, or I'm not going to champion it because I think people are going to get upset at me. And it may be that other people are getting upset because they think other people are going to get upset, and actually maybe we'd be fine with it.
Until everyone's upset then.
Yeah, but I actually don't think that's in the case of pairings. I think that actually there is legitimate opposition to it, just because it's like a new and kind of less tested thing. And then another aspect is the performance. It is slower to verify pairings than it is to verify regular signatures by a factor of about 10, I think. Although maybe we've reduced that to 5. There was some work reducing it to 5. Oh, and then there was a 2016 paper that provided that was an attack on pairings that required all of the parameters to be increased, and then after that, all the efficiency improvements got just like eaten up because he had to increase the parameters. I think it was briefly like more competitive performance, but then it turned out we had to increase the parameters.
So it's a good way to summarize it, just so we don't go on too much about performance. Is the reason why BLS is not introducing the Bitcoin, well, we give you all these lovely unicorn properties that make everyone really happy, is mostly because one is slightly slower at the moment. It's a younger technology in the sense that and it's not battle tested as well as ECDSA or I guess Schnorr in this case. And it introduces a new trust assumption that didn't exist before. But the trade-off is it means you need to design new protocols that work on top of it, on top of Bitcoin, to get similar properties. And they're quite hard to get right so far as well. So it's like pushing complexity up, pushing complexity away from the protocol, but more on the client-side implementation and for what the nodes do.
Yeah, and I think like pairings are definitely a kind of devilishly hard. Like I think pairings are the only cryptographic protocol where even after I wrote an article explaining how pairings work, I still don't feel like I have a full intuitive grasp of like how the heck does this thing possibly exist. So like I think it's definitely fair to have that kind of aversion to it. In terms of just efficiency of libraries, on the Ethereum 2.0 side, we've been spearheading this kind of standardization effort, and this includes the various Ethereum 2.0 implementations. We're also talking to Filecoin, Algorand, and Dfinity, and these other groups. And so there's definitely been a lot of work on, first of all, standardizing around the BLS 12381 curve. This is the one that everyone's kind of rallying around after some of the recent attacks. I mean, Zcash itself has upgraded to it, and then also creating these like really ultra optimized implementations that there's now a lot of pressure to do because the E2 protocol really heavily ends up relying on these aggregate signatures and multi-signatures. So things are improving, but I definitely agree that like efficiency-wise, there's going to be this fairly durable difference between like how long it takes to verify to do a pairing computation versus how long it takes to just multiply an elliptic curve points by a scalar, which is what you have to do in the simpler protocols.
Awesome. I'm going to move topic quickly as well. I just want to finish off with this final topic. I mean, I guess like one big thing we've had throughout this talk in Bitcoin is that Bitcoin doesn't want to do anything on the blockchain. It wants to keep everything off-chain as much as it can. It even wants to reduce the number of signatures you have to verify in the one signature instead of 10. That's the whole point of the Multisig stuff. The whole point there is there's one sig on the blockchain. That one signature is going to do everything. It's going to hide everything, and everything's going to be inside that signature. And the idea there is everything's off-chain. Now, there's two real big, themes in the off-chain world. One is the Lightning Network, and one are these plasma rollups. And I'm just going to give a quick summary just so everyone has a high-level idea what these are about. The Lightning Network's fairly straightforward. You have two parties, Alice and Bob. They lock up coins in this big black box. So Alice puts in one coin, Bob puts in one coin. When Bob sends a coin to Alice, he signs a message and he gives it to Alice, and he says, Alice, you're now the owner of 2 coins. And that's kept private between Alice and Bob. When Alice wants to pay Bob, Alice will then send a new message to Bob and say, Bob, you're now the owner of these 2 coins. So you basically have this like black box where the coins are going back and forth rapidly between Alice and Bob, and all of that is kept off-chain. And when they're done, they close the channel, they send the final balance to the blockchain, and it's confirmed. Now, the nice thing there is that Alice and Bob don't have to trust each other. And when they do a transfer, it's redeemable. It's confirmed. They could instantly send that to a Bitcoin and get their money out fairly quickly. And now with the Lightning Network, you basically have like, multiple channels. And the idea is that if Alice has a channel to Bob, Bob has a channel to Caroline, and Caroline has a channel to Dave, Alice can pay Dave via Bob and Caroline, and they can synchronize a single payment across that route. That's the whole point in the Lightning Network. But there's loads of problems around that. Everyone has to put collateral into these channels, so it's very collateral heavy. And you have to find a route that connects Alice and Dave, and that route might not always exist. And it's only really good for pairwise payments. It's not good for multi-parties, like having, 10 people go join. Like, Uniswap just wouldn't work on Lightning. It only works for, like, a small set of parties at any given time. On the flip side, in the rollup world and the plasma world, the idea there is that instead of trying to confirm these transactions quickly, why don't we sort of just do, like, a big batch? So you have an operator. The operator just waits around, and Alice comes and sends a transaction. The operator's job is to take all of these off-chain transactions, create an off-chain block, and periodically commit that, to Ethereum or to the base chain. So they're basically just a block producer in that case. In Rollup, you post all of the data to the blockchain. In Plasma, you keep the data off-chain, and you just post these little hashes, these checkpoints. The trade-off is that you have to wait around maybe 10 minutes, 1 hour, until the operator posts those blocks. So your transactions aren't really redeemable or confirmed until they're confirmed on the blockchain. Now, the point of using the SNARKS there and these ZK rollups is what you're saying is, I post a block, I can remove a lot of the data. I don't need most of the data now. I just need enough data just that, the blockchain can keep a record of it. And the SNARK basically proves that all the transactions in this block are valid. So this rollup block could have 100,000 transactions. It gets posted to the blockchain, but all you have to do is verify one tiny proof, which is probably the same speed of a single transaction. And then you can verify that this entire block of transactions is correct. So what you're really keeping off-chain is the computation. The data still hits the blockchain, but most of the computation is kept off-chain. So it's a bit like the Bitcoin. It's actually a bit like the Bitcoin ideology. You should do minimal computation on the blockchain as much as you can. And you take all of that off-chain, and the operator just batches that all together. So it's like a very high-level overview of, Lightning versus rollups. And if you didn't understand that, I'm sorry, because, you guys do, but anyone listening, because trying to describe that within 2 minutes is hard. So one thing I wanted to bring up, because I guess, Vitalik, you've been talking about rollups a lot. What do you think's the holdup so far? Now, the gas prices are a bit crazy at the moment. They're 400 or 500 gwei. Causes $6 to do a single transfer. What do you think have been the bottlenecks for the rollups?
So there's two families of rollups, right? There's the optimistic rollups and the ZK rollups. So the main difference being that optimistic rollups use fraud proofs. So the operator publishes a block and they just publish what they claim is the result. And then if they're wrong, then someone else would basically publish this fraud proof and in that case, what would happen is that the entire computation of that particular block would actually be run on chain. So it's this kind of interactive game where you only do computation if someone thinks that someone else is wrong, and whoever's wrong ends up losing, like a bunch of money in their deposit. Or you have ZK rollups where instead you use these zero knowledge proofs to just directly prove validity without needing interactive games for it. And surprisingly enough, right, it's the ZK rollups that came first. And you might think that optimistic rollups are simpler because they don't rely on the fancy stuff, but I think the reason why the ZK rollups came first is because the optimistic rollups are trying to do more, and they're trying to do more because for now they can do more, right? Basically, the challenge is that zero-knowledge proofs tends to be really good at structured computation. So we're at a computation where you can put all the computation in a big table and you verify the exact same equations millions of times, and it's very efficient if you describe it in that format, which is good for, like, say, hash verification and signature verification. But for general purpose computation, efficiently making a zero-knowledge proof is much harder, right? And it's considered to be one of the kind of holy grails of snarking, to be able to kind of snark general purpose virtual machine execution. And there has been progress. So, like, for example, the Aztec team, which did Plonk, they released this thing called Lookup, which allows efficient proving of functions with lookup tables, which is actually a significant boost to virtual machines. And there was the Cairo from Starkware, and I think they use some similar technology in some areas, but not in other areas. So it's been improving, but it's still quite far from being able to kind of practically verify EVM execution. Whereas an optimistic rollup, like, okay, hey, you got the EVM, and like you can just like go and write whatever verifier you want, and it's not particularly hard, right? So optimistic rollups, they're trying to do more, and what I mean is they're trying to support basically an EVM equivalent environment on top of a layer 2. And that's something that the developers love, because for a developer, what that means is that they can just take their existing application, they just like hit compile and hit deploy again, just using slightly different software, and it works kind of roughly the same way that it worked before, except the fees that would be 100 times lower. Whereas with a ZK rollup, it's just for payments or DEX or a couple of other use cases for now, right? But on the other hand, the ZK rollups, we already have Loopring on chain, we already have ZK Sync on chain, we already have Starkware's Diversify on chain, and in the rollups, and the third, I'll briefly mention the third category, Plasma, right, which has more off-chain data, the OMG network, which is also payment specific once again, right? So the payment specific stuff already exists. So, the Internet of Money does cost less than 5 cents a transaction again. Yay. But the more general purpose application things don't yet exist. And it looks like technology for those will be ready in a few months. But, that's the thing that I think most people are waiting for, because if ultimately Ethereum is all about doing things that are more than just moving coins around. So that's what people are expecting.
Yeah, I have one question for this, and then I'll move on to the Bitcoin stuff, because there's obviously a Bitcoin podcast. So, so my impression of the rollup, so you have ETH 2, and ETH 2 is a sharded solution, and it's being built, but if you look at rollups are like shards, and the idea of a shard is that only the people who are in that shard, in that blockchain, care about validating it. If there's a shard for hotels and a shard for train bookings, If I'm not booking a train, I don't care about the train bookings. I just care about the hotels because I'm booking a hotel. So do you not think like rollups is a bit like getting a sharded solution into Ethereum through the back door? And it might even look a bit hacky, maybe a bit like the evolution of all these cryptocurrencies. They're all hacky. And maybe that'll take over version 2.
Right. So rollups are powerful, but they do have the one limitation, which is that you do need some amount of data on chain for every transaction. And the reason why you need data on chain is basically because in order to guarantee that people can withdraw, you need to have enough data on chain so that anyone can reconstruct the rollups internal state, and if the rollups internal balance Merkle tree that contains the balances and so forth. And so it's about 16 bytes on chain for the rollups that are designed well, and that's 6 times less than regular transactions. But then the scaling factor goes up to about 100 because you get rid of all the computation, right? But there is this amount of data, and so ultimately the capacity of the system is bounded by something like 3,000 TPS right now. And in the long term, if we want to get more users and more cheaper non-financial applications, we're going to have to go even higher than 3,000 TPS. And so that basically means scaling the data layer and designing the data layer in such a way that you can verify its integrity without every single participant having to personally download and check the kind of availability of all of the data. So that's kind of the core technical reason why I think in the long term, if we want to kind of achieve the system's full potential, you basically need to have rollups and sharding and stack the two on top of each other. But if you have different trade-offs, so you could definitely get to a medium level of scalability with just rollups.
Yeah, so I guess I'm just going to summarize that. So I guess with rollups, because most of the computation doesn't happen anymore, via the blockchain, the main bottleneck to scalability is no longer computation. It's really just data availability and sending data across the network between all the miners and the users, and that's why you can increase the throughput for that. Now, obviously, these techniques don't work in the Bitcoin world today, and there's a very good chance they're not going to work in the Bitcoin world in the foreseeable future. But Bitcoin does have the Lightning Network, which is another type of scalability. So I do want to ask Tadge, so obviously Tadge was the inventor of the Lightning Network. You were thinking about a lot of these protocols back in 2015. Have you seen the evolution over the past 5 years? I mean, it's live now with, last I checked, it was 30,000 Lightning nodes, but that's actually not a good stat because some of them are hidden. How have you found the evolution over the past 5 years of seeing your little baby be, written up and designed, and now it's deployed and implemented by a crazy Bitcoin army of developers?
Yeah, I'm not. So it's kind of interesting. I'm really not as involved. I sort of have been working on UTREEXO and other systems in Bitcoin, and I guess it's because there's so much development in Lightning, and it's sort of like, well, everyone else is working on it. It doesn't, it's if all these other people are working on it, maybe it doesn't make sense for me to work on it as much. And also because it's sort of like, I don't know, I guess, because I sort of co-authored it with Joseph, it's like, well, it's sort of quote unquote mine, but it's not, right? It's Lightning Network. Anyone can use it. And so it's kind of hard to work on it because it's like, well, this was my thing, but no, it's everyone else gets to use it. I don't know. I guess, if Vitalik, if all these other people started working on Ethereum and you sort of disagreed with what they were doing, that might be kind of annoying because it's like, you didn't, it's not your network, but at the same time, it's like, well, I kind of came up with some of these things. So I think it's awesome. But there's a lot of things that I would change. And so that sort of like bugs me. So it's like, other people are working on it. I'm going to focus on this UTREEXO and accumulator stuff. And who knows, maybe, a year or two from now, once that's like taking off and people are using it, work on some other thing. Just because, and I think it's sort of a good way to work on it because you don't want to have, you don't want to have people in charge, I guess. At least I don't want to be in charge of things like that. But overall, it's really cool to see, and it's really cool that people are using it. It did sort of weird me out in the beginning when people like have these little lightning emojis in their Twitter, and like especially with the like Bitcoin Cash and block size, and it was like getting to be this like thing, and I'm like, whoa, I don't want to get involved in that. But technically, it's really cool, and like a lot of the stuff that like Rusty and Lightning Labs and people are doing is really cool.
Yeah, so one thing for Lightning I want to bring up as well is, so Lightning, in my opinion, so we can all challenge this, I don't think Lightning's very good for payments. What I think Lightning's really good for is synchronizing two off-chain ledgers. So a really good example of this, there's a startup called ZBD doing gaming on Lightning. But what's really cool about it is that I'm playing like Street Fighter with someone else and we're fighting. Someone watching the game can scan a QR barcode, they can send sats to the game, and then they can buy me a power-up. But actually, that's not really a payment. What they're really doing is they have a ledger on Blue Wallet, which is, I guess, in this case, fully custodial. And they have another custodial wallet that's a game. But they're using Lightning to synchronize the payment across the two different ledgers. And I think use cases like that are mostly unappreciated at the moment. But I think that's probably that synchronization between two ledgers, for me, I think is going to be the killer thing for Lightning. And not necessarily people buying stuff in a candy shop.
Plus, yeah. So
I don't know. I just wanted to see what your thoughts might be on that.
I definitely. Well, I am sort of surprised that exchanges aren't as supposed. Because initially, when working on it, I was like, we should talk to exchanges. Like, this is the premier use case for this. Like, instead of having a deposit or withdraw button, you now have a like fund channel and like close channel button, and you're not custodial, right? So you can still. Because that's what a lot of usage is trading and exchanges. And it seems like great. And I did sort of think that was how the network would sort of build up. That, Coinbase would have a big node and Kraken would have a big node. And then like, the users would have channels to these exchanges. That hasn't really happened. It is starting to, I think. And that would be really cool because that to me seemed like a great use for it because you can get rid of this sort of custodial problem with all the exchanges. So hopefully that does go forward too.
Yeah. So one thing I just want to add there is, so the idea there is that I'm an operator. I'm Coinbase. There's these massive whales. So you have coins in my service, but they don't always want to keep their coins in my service. And they set up a Lightning channel with me. They could quickly deposit, do a trade, come back, quickly withdraw, and they can minimize their trust in me. That's sort of, I guess, what you were alluding to for that use case. What I do see, so I think there's two parts there. I think one of the use cases I see exchanges could adopt is you have like, Bitstamp and maybe Bitfinex. They have a Lightning channel in the middle, and they just support transferring coins back and forth between the exchanges. Because that's what most people use these cryptocurrencies for anyway. They just transfer tether from exchange to exchange to get some arbitrage moment. And
isn't that what? Sorry, just to jump in there. Isn't that also what Liquid is pitched at doing as well?
Exactly. Yeah. So Liquid is basically a federation. Actually, maybe Andrew, do you want to describe that since you're working on that project? Yeah, maybe compare the Lightning, like the differences.
Yeah, I get asked this a lot, so I guess I should come up with like a simple, punchy one-liner. Basically, the way that Liquid works is Liquid's a separate blockchain. So everybody who participates in Liquid, there's kind of an unlimited number of people who can participate. They take Bitcoins, they peg it into the Liquid chain, by which I mean they send the coins into the custody of a federation, of a quorum of 15 federation members. And then while coins are in the Liquid network, basically they just move around on the Liquid blockchain, and every block is signed by a quorum of this federation, by I think 11 of these 15 participants. So to sign, and then later when people want to move their coins back on the Liquid blockchain, they basically raise a flag. They have a special kind of transaction that says, please give me my coins back. And then the federation, who has physical custody of the coins on the Bitcoin side, will then send the coins to the right person. So if you were using Liquid such that the federation consisted of 2 people and those 2 people were the only user of the system, then it would be similar to a Lightning payment channel. It would be the same model. But morally, the difference between Liquid and Lightning is that in Lightning, the people who have custody of the coins are the actual counterparties of the coins. And in Liquid, the people who have custody of the coins is this extra object, this federation. And the benefit of that is that you can have like arbitrary number of participants who are all acting in sync, and you don't need to have payment channels that are chained off of each other and worry about scalability issues related to that. But then the trade-off, of course, and another benefit is that by having a separate chain of blocks, we can have confidential transactions and all of this cool, like whatever crypto shit or experiments we want to do. We can do that on Liquid. On Lightning, you have these individual payment channels, which are 2 people who are basically maintaining a state which consists of a valid Bitcoin transaction. And anyone can close out the channel by publishing the transaction to the chain. So you're largely, but not entirely, limited in Lightning to doing things that you can do on Bitcoin. So like the Bitcoin technology capabilities is the same as the Lightning technology capabilities. And then also when you're connecting more than 2 people, there's a bit of a technical thing where you create these paths that are all linked to each other. But the biggest difference, I would say the biggest difference is the custody model, basically. In Lightning, your coins never leave your custody. In Liquid, there's this federation trust requirement.
Oh, I think there's a collateral difference as well. So in Lightning, if I'm Coinbase and I have 1,000 channels, the collateral lockup and management I have must be a headache. Where if you use a side chain like Liquid, the operator doesn't need any coins up front for the system to run.
That's a good point.
Coins and you go.
You're right. There's no the collateral. When you move coins into the system, you are putting up those coins, and then they are in control of the federation. And when you take them out, they come out of the federation. And there's never any collateral beyond what's actually in the system. There's always one-to-one, no pre-funding.
Awesome. Yeah, so actually, you just made me think of this. So maybe the good way to categorize is that you have a side chain, like Liquid, and you're trusting the federation, head of any of those federation members. A roll-up is like going a bit further, where you trust the base chain for security, as opposed to federation. You lock your coins into a smart contract, they get unlocked in the roll-up, but you still have this block producer who can really only censor your transaction. Because if they censor the block or your transaction, you just withdraw via the base chain, you get out. And then Lightning's on like a different angle. No one can really see my picture, I guess, so I'm using my hands to try to describe this. Lightning is sort of like, to me, is a nice way to synchronize these 2 different ledgers between side chains and roll-ups. So if you're a Coinbase, for example, instead of having a massive, huge channels of all your customers, you just run a side chain or you just run a roll-up, and then you use Lightning to jump in and out really quickly. To me, that just seems like the ideal setup. I don't know if you guys have thought about that before. Anyone
Cool
can jump
thought.
in if they
In
want.
the original sidechains white paper, that was sort of Blockstream's like announcement paper. We speculate a little bit. I haven't looked at this paper since I wrote it in 2014. But like near the end, we sort of speculate on future direction. We're like, oh, if we had like fully general zero knowledge proofs, and if we had support on the Bitcoin blockchain, then we could do sidechains in this much more efficient or much better way, where you have Bitcoin ultimately, or the main chain, whatever that is, ultimately enforcing all the transfers, and then you have these like magic, at the time unimaginable zero knowledge proofs, making that something that was tractable. And that is very similar, I guess, on a high level to what rollups are doing. That's a neat that I hadn't considered that connection.
Vitalik, do you have any comments? You're quite quiet now.
You haven't directed any questions at me yet, and I'm just happy to listen. And I think like payments and the kind of Plasma rollup family, like I definitely don't like thinking of Plasma and rollup as being the same thing, but they're different, but they're definitely more similar to each other than they are to channels. So they have different benefits and kind of different properties, right? So like channels, for example, are vastly superior when you have repeated transactions, right? So like any kind of payment for a subscription and make a lot more sense, and definitely kind of settlement between like institutional actors that each represent a lot of people. Like that's another one of those cases where you have a lot of repeated transactions, and so anything channel based ends up making a huge amount of sense. Another kind of important benefit of channel-based solutions is that you get instant transaction confirmation as opposed to having to wait for the transaction to get some transaction to get included in a block to get some degree of security. But on the other hand, the weaknesses are like one, it's like conceptually more complex. You have these kind of routing issues. You have the capital lockup issues. I mean, you have like potentially even a trade-off between the system becoming centralized versus the system having very high capital lockup and all of these things, versus on the other side of something like a roll-up, it's like, or even a Plasma. Well, the ideal is a ZK roll-up because you can get all of the properties with like basically no capital on top of what's stuck inside of the systems, right? If there's $100 inside the thing, you need $100 to secure it. With optimistic rollups and Plasma, you can technically get away with the same thing, but it's better if you have more collateral, basically, because that way what can happen is you can kind of buy up people's withdrawal slots in progress, right? Like when you start a withdrawal, someone else, like normally the withdrawal will take like say 7 days or 14 days or whatever to process, but someone else can just kind of buy up your withdrawal slot. They'll give you 99.99% of the amount. And then they would kind of put up the capital for the 2 weeks themselves, and so you'd get the instant withdrawal experience, and they'd get like some interest for putting up the capital for that period of time. So it depends on the situation. It depends on the use case, and like in the long term, I'm expecting kind of all three of the design patterns to be popular in some form or another.
Yeah, if you guys want, actually, what I can do now is I can summarize the discussion we've had on the podcast. Then everyone can have like a final word if you want, and then maybe Peter can wrap everything up. Maybe that's worth doing now.
Yeah.
Yeah, because I know it's a bit of a long episode.
No, it's fine. It's fine. I mean, it's 10 to 1 in the morning.
Yeah, I can.
It's late for you and I, hey, Paddy.
I had a nap earlier. Yeah, I had a nap at 5 p.m. for this because I knew it was going to be late. Okay, I can just summarize basically what we've spoke about for the past 2 hours. We started with the origin story and the narrative. Bitcoin was introduced to the world as a system to protect people from fractional reserve banking and limited inflation. Satoshi was not very shy about that. One thing we didn't talk about was Satoshi also implemented a casino in the original client. I don't really understand why he did that, but he did. It's been removed, I guess, since. Later on, the story started to emerge as a sort of peer-to-peer payment network that was this decentralized, anonymous, scalable network. That was when I got in 2013, 2012, and obviously that wasn't true at all. It's not the most traceable currency in the world. But then this third application started evolving on Bitcoin that was like building these applications on top. This is like Satoshi Dice, Mastercoin, Colorcoin, OmniLayer that basically powered Tether for a lot of years. And I guess that's what Vitalik and Ethereum picked up on. And when they started doing Ethereum, they were going to build on Bitcoin, but they built enough critical mass, and they just went and deployed Ethereum. Then we sort of spoke about, the Frankenstein systems. Both of them have sort of like grassroots, effort, and they all have these very quirky bugs that make them both really awkward and difficult to deal with sometimes. Bitcoin had lots of early bugs. It still has some bugs because you can't really get rid of them, like the signature, for example. Ethereum has lots of different attacks that we didn't even really explore, to be honest. There's lots of problems in the Solidity we could have explored. The biggest issue is basically a security audit, because people deploy these smart contracts in production a lot of the time, and then you get the security audit afterwards, or it's just too expensive, you don't get it done. But obviously there's a lot more work towards formally verifying these contracts and building better tooling to get rid of most of the common bugs like Viper that Vitalik was working on. And then going down through that, we spoke about scalability of the network. Bitcoiners are like assembly programmers. They know every nitty detail. They don't want any computation on Bitcoin. They just want Bitcoin to do signatures in small conditions, and that's it. And even with signatures, they don't want to verify 10 signatures. They want to compress it to one signature. So all you have are signatures and nothing else. But a lot of work on Bitcoin around scalability, they didn't have to change the consensus rules. They didn't have to change the protocol. They just made the software way more efficient. So now you can still verify the blockchain in like a day. That's a good effort on their part. In the Ethereum world, it sounds like there is a lot of optimization on the hardware, and one metric was the uncle rate. I won't explain what the uncle rate is, but it went up for a bit and then back down to 7%. That demonstrated the software got more efficient because there's less forks on the network. But a lot of the changes are focused on the protocol. ETH 2 is taking a lot longer than everyone expected. And then we went on the off-chain scalabilities as roll-up versus Lightning. And I think that's basically the summary of the entire podcast in a very nutshell. Vitalik, do you want to go first with some last words of what you sort of want to leave with? Oh, and one last thing. The whole point of this discussion was really to highlight the differences and the benefits of both networks. And hopefully you'll all see that they both are complementary and have different goals. I don't really need to illustrate those goals now, but they both have different goals. Vitalik, do you want to just have some final words?
Oh, I see. I guess it's a reverse alphabetical order this time around. No, again, I definitely agree with all that. I mean, I think there's definitely some different goals going into a lot of the systems, the two systems. So I think there was also a kind of a lot of shared values as well. I mean, like at the core, we are both trying to build kind of maximally trustless and secure systems, and like help people do things without having to kind of put basically give all of their assets to a centralized intermediary for the duration as much as possible. And there's definitely kind of different applications that are being emphasized at different kind of security trade-offs on the edges. But I think whether it's kind of ideologically or even technologically, as we've seen with like how both networks use the SecP library, for example, there's definitely a fairly big kind of shared core, and that's something that probably is important not to forget as well. So I'm just looking forward to the next 10 years and seeing how the rest of the technology ends up getting rolled out and how the ecosystems have come to fruition.
Tadge, do you want to go next? I'll just go
sure. I
can reverse order now.
Sure. So I actually sort of worked a little bit on Ethereum, before there was the whole sale and stuff, like, some of the hash function they looked at for their proof of work, and I, sort of talked to people back then, but have been working mostly on Bitcoin. But it is interesting. I definitely do read like ETH, or I don't know how to say it, ethresearch.ch or whatever, and try to keep up. And it is, to some extent, there's a bit of a loss because of the sort of different philosophies and different things there, because there's not much communication between the two groups, right? And it makes sense to some extent. But like, at a conference in, February before the whole COVID thing, I remember talking to some people who were working on stateless clients in Ethereum, and it was like, oh, we should talk about this more. And then, we left and we're sort of in different worlds. So I think it would be cool if we got to learn about how Ethereum solves similar problems to Bitcoin has, because at the core they are dealing with like very similar issues, right? Like we both have these big level DB things with like millions and millions of entries, and it's like, okay, how do you scale these things? They're taking very different approaches, but I think it makes sense for people who are interested in Bitcoin. So, for example, this podcast is a good example where, I'm mostly interested in Bitcoin, but I definitely keep an eye on Ethereum and try to read what they're working on and how they're doing it. So I think that, and hopefully vice versa, right? And people in Ethereum can look at what Bitcoin's doing and take libraries in both ways. So hopefully, it can be a mutually beneficial thing. I think right now it is somewhat standoff-y, and there isn't a ton of interaction. I don't know, maybe that'll change in the future.
Yeah. So I guess
Andrew,
I'll
you wanna
second
go next?
the comment about there being a lack of communication and that being kind of an unfortunate thing. I also speak to a fair number of people in the Ethereum world and generally in the altcoin development world. Usually I'll just encounter them when I'm visiting friends in Boston and the MIT area. I'll just sort of wind up in rooms full of people who I don't otherwise tend to talk to online or at conferences or whatever. And part of the reason I would say, or certainly a large part of the reason that I don't tend to reach across the aisle so much, is that a lot of, especially in like 2017, really, there's a lot of irrational exuberance. There's a lot of like scam coins and things like this that for a long time were using Ethereum as a basic platform. And as Vitalik has talked about how things get more expensive and maybe like bad ideas get priced out, and unfortunately maybe some good ideas, things certainly have calmed down, and the Ethereum world is much less irritating than it has been in the past. There's a lot of like cool, like genuine research, versus people who have like white papers full of fluff where they've claimed to have solved problems that are impossible to solve and so forth, and who are raising like billions of dollars in exchange for just like this kind of fluff. We've seen that sort of go away from the wider cryptocurrency space since 2017, and in particular, I think there's a lot less of it in the Ethereum world. And in its place, I'm really excited by what I see. I'm really excited by the kind of research into different plasmas. I'm excited by the research into off-chain stuff. I'm excited by the ZK rollup stuff. I'm excited by zero-knowledge proof development in general. So one thing, we didn't go too much into kind of philosophical disagreements in this discussion, for better or worse. But certainly I would say, Vitalik, almost everything that you guys propose for ETH2, I think is just like you're biting off more than you can chew, and like it's never going to happen. And I'm really glad that y'all disagree with that assessment and that you're driving forward the kind of basic research that is needed to create these things. Because if we have efficient zero-knowledge proofs, if we can achieve that holy grail, then that would be incredible for everybody, including Bitcoin and including a lot of the research that I do work on day to day.
All right. Well, listen, I'll close out by saying I pretty much didn't understand 90% of what was discussed this evening. But it was I'm glad everyone could come together and have a chat, and it was useful for you, or it kind of proved something for me actually, that actually this stuff, some of it is way too technical for certain people who might be investing, and actually I don't think people do always need to hear this. I think sometimes actually perhaps like a show sometimes that I do with you, Tadge, or you, Andrew, where I get you to explain the fundamental, the basics, the simple bits I need to know, helps people to have that like kind of like limited small amount of knowledge. I'll be interested to see the feedback on this. I think there'll be some people who'll be great, like really glad to hear it. The fact that they've got Tadge and Poelstra and Vitalik all together, I think it's going to be mind blowing for some people, and I think some other people may switch off and go, that was too much for me. So it'll be really interesting to hear the feedback. But if if people like yourself, Tadge and Andrew, you can benefit from some of the research and perhaps build some relationships out of it, then I think that's a good thing. But yeah, let's see what the feedback is. But thank you all. It's 1 a.m. I'm shot. I know Paddy's going to be a little bit as well. But yeah, I appreciate you all coming on, and I wish you the best. And let's see what people think of this. Okay, what did you think of that? Is your head hurting? Yeah, that got pretty high level sometimes. And honestly, I was lost for a lot of it. But I think most of you would expect that anyway. Now, I think some of the techies will have gone a lot for this, and hopefully some of you less technical, you may even enjoy it as well. You may get something from it. Now, after doing a couple of shows on Bitcoin versus Ethereum, my views haven't really changed that much. I wasn't a maximalist, and I don't really like to label myself as one, but I don't have Ethereum. I don't hold Ethereum. Look, I don't think it's a scam the way some people think it is. I think it's used for a lot of scams and a lot of bullshit. I don't fundamentally see a blockchain itself as a scam, and some people argue differently, but nothing's changed. I have no interest in buying or holding Ethereum, but it was definitely a useful exercise for me, but it will be back to Bitcoin now. I think my little venture into Ethereum here has done what it needed to do. But you know what? I hope you got something out of it. I hope it was helpful to all of you. And yeah, Jesus, it was a long enough show, so I'll shut up now. Any feedback, you can reach out to me. It's hello@whatbitcoindid.com. And outside of that, have a great week, and I'll see you all soon.